by ourselves. That is important. And also, we have to current the policy, the satellite policy, because technology is changing, and also opportunities. As you know, there is a new constellations, low Earth orbit constellations that are emerging. So we have to share services to complement with those new constellations. There are some examples like Amazon, like Starlink from SpaceX. They are launching many hundreds, thousands of small satellites for internet. So we have to share the services with those satellites and sometimes to compete with them with our geostationary orbits. So what is the final goal of this? To accelerate the digital transformation, to the connectivity, the social inclusion. So we are working on that. In this part is the telecommunication and navigation. We are having an agreement with Galileo that Mexican Space Agency can be part of this project with other organizations in Europe. So we are working on that. As a matter of fact, in Mexico there is a information center. Later, the person of UNAM is going to explain that. So, can you change the next one, please? No. Okay. Talking about air observation. Well, you can see all applications that are in the list there. In the environmental monitoring and global science, in this part is included all related with natural disasters, droughts, floods, fires, hurricanes, and earthquakes. But in all these applications in Mexico and in the region, we need a lot of images from the satellites. So in that way, we have been working with industry, and industry has invested already in the GeoSat satellites. The former name was the Deimos, but now is GeoSat, and the Mexican industry has invested there. So this is the first step to go to have our own constellation. That is the plan, to have a air orbit constellation for Mexico, but we can share with other countries. So once we have the satellites on orbit, we can have several countries and coverages. So in this way, this is the first step that we did, but the final goal that we are looking for is to have a constellation. Right now, we receive images from several foreign satellites, but as we have our own telecommunication satellites, we intend to have our own air observation satellite. And one project related with air observation is that the second generation of ASTECSAT. You know that the first generation was launched to the International Space Station 2 years ago. That was the first satellite made in Mexico to be in the International Space Station and then deploy from there. So this is the second generation. The second generation, we are going to have five nanosatellites. We are working in this project with NASA and with some universities. So the plan is to launch this constellation in 2024. And it's not only for marine mammal science, it's also for lunar exploration. We are going to take advantage of this constellation also for the future projects for going to the moon in this decade. So we are already working. We have the basic design of the project, but we are going to start in 1 or 2 months. We're going to start to make the satellites. Each university is going to make one. Another project that we are working on is the OMECA, the Mexican Observatory for Climate and Atmospheric Composition. So this is very important for climate change, and this is the goal is to measure carbon trace gases and vegetation health, to evaluate the impacts of the human activities like industry, like urbanization, transport, soil use, and inventories, to have inventories, improvement, and quantification of emission with invest nodes. Identification of risk zones, droughts, vegetable coverage, crops, health, etc. So for this project, we are going to use also the GeoCarb satellite from NASA that is going to be launched next year. So we are going to compare the measurements of the satellite with the measurements of the station that we have here in Mexico, to correlate and to compare these measurements. You can see in one of the photographs in the blue one, one is the measurements of the satellite, and the other one is the measurement from the station, from the Earth surface. So we compare them and clarify the results, and we apply to the factors of climate change and how climate change impacts on the several applications like agriculture and so on. So this is another important project that we are working on. Also in space exploration, at the end of this year, we are going to have on the surface of the moon one constellation of micro robots, where this project was designed at National University of Mexico. We support them with some resources, economical resources, finance, and also CONACYT participate, and the government of the Hidalgo state. So at the end of this year, they will take these micro robots to see the mobility on the regolith, in the surface of the moon, to see the facility that micro robots can move easily, automatically, to have electronic connection, to have physical connection, and to have a solar array on the moon. This is one of the projects. So we also have been working in Mexico in projects on Mars, mainly with the rover Curiosity that is still working there, is still alive. In this project, in Mexico, we have very good scientists and researchers But before I show the researches, this is another project in which we are working with Airbus and Jerome. Jerome is a new young company, but they are working very hard in this area. We depend on some budgets, but the objective of this project is to have a rover to take lunar samples and regolito, and then to take with a robot to a gas terminal to convert the regolith to oxygen, and also to convert the regolith to some metals, because it's important to start to produce materials, produce oxygen at the moon. We in the future, it's not possible to take everything from the earth. So we have to produce things at the moon. This is the part of the Mars project. With curiosity, this was astrobiological research performed by Rafael Navarro. Was a scientific, famous scientific. Unfortunately, he's died, but he made a lot of contribution for the Mars exploration. In that way, NASA proposed to put his name to one of the Mars mountains. But the research here was to identify ancient organic compounds on Mars, and he did some research, laboratory simulation, field work, and theoretical modeling in chemistry, physics, and biology. So we have, as a country, we have experience also in the Mars projects. Talking about human capital, there are several alternatives here, possibilities. One is to promote at the Mexican universities new academic programs, undergraduate and graduate programs. There are universities that are offering some programs, but they are not enough. So we need to increase, to strengthen these possibilities. We have agreement already with some universities to have a master program or a undergraduate program or a PhD program. This is one way. The other way is to have stays of Mexican students in some agencies, in some space agencies around the world. So we have already one program with NASA, very success program. They are there for 3 or 4 months, working in real projects and doing a very good job, because our youth is very, they have a lot of talent. And NASA has seen this, and sometimes they want to keep them, to contract them, because the capacity that NASA sees on these young people is very big. That is the other point. Not only with NASA, also we send our students to India, for example, to the Indian Space Agency, and to the European Space Agency. And the other is that we involve to the students with practical projects. The first nanosatellite that we make, I mentioned at the beginning, around 80 students participate. So this is a very good way to form new experts. This is to take advantage that the capacity of the students and to participate in real projects put in the hands. So we are going to do the same with the next generation of AztecSat. We are going to involve students in addition to the researchers and professors. And now this project, as I said, the participation of the universities you can see there, and also industry and NASA. NASA is going to participate with the launching of the satellites and with the final environmental testing. In international cooperation, we have agreements with the main space agencies. We are a part of the G20 countries, so we have relation with the G20 space agencies. So we have agreement with NASA, with JAXA from Japan, with ESA from Europe, from Roscosmos, from ISRO, from India, from CONAE. We have agreements con NES from France. And we would like to sign an agreement with CARI. I think that this is the best time to do that in order to start to make concrete projects together, to have a collaboration. One possibility is to participate in the first Latin American nanosatellite that we are planning. So you can see here also our participation in United Nations with UNOSA and with CELAC. With CELAC, when Mexico was the president pro tempore, they had a list of important scientific and research projects, and the main one was related with space. That is the reason, because in 2020, Mexico signed the declaration of establishment of a regional cooperation mechanism in the space field. That was 2020. That was the first step. And this declaration was signed by Mexico and Argentina. But later, you can see there in the National Palace with the Mexican President, López Obrador, was signed the Constitution agreement. It was signed by 21 countries. But the next step now is that regarding the agreement, it's necessary that 11 ratify the agreement. So far, they have ratified 6. We need more 5. The ratification consists in the Congress. It depends on the Congress. In the Mexican Congress has already ratified also. So we are waiting the other 6 countries to complete and to start operations. In the industrial part, we have more than 300 aerospace industries in Mexico. Most of them are related with aeronautical industry. But some of them have the capacity, the orientation, the interest to go to the space area. So we have to take advantage of that. Very few countries have these capacities. 300 industries, more than 300 industries. Some of them are already working in the space part. I want to say one example. One of these companies is already working with SpaceX for components to install in the rockets of SpaceX. So that is one example. There are another examples that they are doing another things. So that is very good for us because we can accelerate the construction of satellites, the construction of telecommunication satellites, air observation satellites, and another equipment for space. And we have our regional space centers. One is in the north, is in Zacatecas, with several labs like space instrumentation, modeling and simulation, electronic design, integration, and test for space system, software-defined radio, and RF, and Internet of Things systems, antennas and RF, and autonomous mobile systems. So in this center, we have collaboration with universities, mainly with University of Zacatecas. We have experts there, working there in the center, and also students. That's very important. We have students working in the center. So that helps us to work on our projects that I have mentioned. The other center is in Atlacomulco, in the state of Mexico. It is 2 hours from here. And this is this is oriented to air observation, analysis and image processing, satellite design and development, also related with air observation, rocket designs. We have a lab for rocket designs, and also technology transfer and extension service. This is for having new small companies, startups, to promote the creation of startups companies, and also the area of capital, human capital forming, because we have all the facilities to have classes, to have laboratories that the students can be there, can participate there. And also we have agreements with the regional universities. There are several universities around there, and also we have the experts from the universities to make joint projects, to work together. So this is one example of having facilities where industry, where academia and government are working in space projects. So I think that this is all I wanted to say, but what I am saying is how to put together government, academy, society, industry, environment, and the important thing is to have innovation. But what is the final objective of space activities and space technology? The final objective is people. That is the final. And one thing is inspiration for all, for young people, for experts. Another is innovation for new technologies, for new business, for new companies. And the other is to care of the planet. And the final is to discover the universe mysteries. Thank you very much.
Thank you very much, Dr. Landeros. Again, we have a couple of minutes if you have any questions or comments from the audience. I see one here with the gentleman on the left-hand side. Hang on.
Muchas gracias para la presentación. Me llamo Andy y soy desde Satrek Initiative. Somos una empresa en Corea que manufacturamos y diseñamos el satélite Deimos 2, que estaba en su presentación. Mi pregunta es que ¿tienen planes para desarrollar o obtener satélites más grandes? Creo que he visto 5 satélites que estaban trabajando con NASA, pero creo que esos satélites son pequeños. Mi pregunta es que si tienen planes para obtener satélites más grandes, no nanosatélites.
Sí, eso es lo que estamos planeando ahora mismo, ver cuál es la mejor opción de ir a la siguiente generación de satélites de observación de la Tierra. Hay varias alternativas. Una alternativa es tener 3 satélites ópticos y 1 de radar, o sea, 4 satélites pero grandes. Otra alternativa que estamos analizando es participar en una constelación de satélites, no nanosatélites, pero en una constelación de 16 satélites de 25 kilogramos cada uno. O sea, no son tan pequeños, pero no son tan grandes. Esa es la segunda alternativa. Y la tercera alternativa es tener una constelación de satélites para la región de América Latina. Entonces, estamos en esa planeación, pero sí queremos ir a satélites más grandes.
Is there any other question here? I see 2.
Antes que nada, muchas gracias por la presentación, doctor. Mi pregunta va orientada hacia el desarrollo de sitios de lanzamiento. ¿Se tienen contemplados desarrollarse en México debido a la extensión geográfica del país? Y si es así, ¿qué avances se tienen al respecto?
Bueno, ya algunas de las empresas están haciendo inversiones para cohetes, pero todavía no tenemos bases de lanzamiento, entonces esos lanzamientos los van a realizar desde New Mexico, desde Nuevo México, donde hay una base de lanzamiento. Pero necesitamos planear una base de lanzamiento en territorio mexicano. Se necesitan inversiones, eso es lo que andamos buscando, inversionistas, y tenemos varias opciones de sitios, porque se dan opciones para poder tener la base, por ejemplo, en la península de Yucatán, en Chiapas, en Baja California, O sea, tenemos varias alternativas. Lo que estamos buscando es los recursos, las inversiones, que pueden ser inversiones público-privadas o pueden ser inversiones privadas. Pero sí ya nos empieza a urgir, a acelerar este paso para tener bases de lanzamiento, porque tenemos el laboratorio de diseño de cohetes y tenemos las inversiones que ya están haciendo en la fabricación de cohetes la industria mexicana, pero nos está haciendo falta las bases de lanzamiento. Es un tema importante que tenemos que acelerar.
There is one more question here, and I'm afraid that this is the last one since we have to stick to the schedule. Thank you.
Yeah, I'm Chong Park from CARI. Thank you for your presentation. And Mexico signed the agreement of Artemis last year, and Korea also signed that agreement. And do you have any specific plan how to participate in the Artemis program and to collaborate other countries, United States and Korea can be one of them? Yeah.
Yes, we signed it, the addition to Artemis in December 2021, and we have the opportunity to participate in some projects to the moon. And for that reason, about 2 months ago, we signed an agreement with NASA to have this Aztec constellation. Because, as I said, it's going to be useful not only for the mammal animals, sea animals, but also for lunar exploration. So that is the first step. The second step is that we are working in that project that I mentioned to convert regolito to oxygen and to produce also some metals. That is another project related with Artemis. And a third project is that we have received invitation to participate in the construction of a new space station. This new space station is going to orbit the Earth, but it will be useful for the gateways that are going to be on the moon. So we are going to assimilate knowledge and technology with this project. And also, for this project, we are invited to propose scientific experiments. So we are in that way. I want to say that they are not the main projects to the moon, but they could be just one part of projects to the moon. And then to Mars. The first stage is the moon, and then to Mars in the next decade.
Okay. Thank you very much, Dr. Landeros. So now we're going to change moderators. I'm going to pass the microphone to my colleague, Mario Arreola, who will present the next session of the day. So thank you very much, and keep enjoying this seminar.
Please, an applause for Dr. Landeros. And I am pleased to announce from Korean National Space Development Plan and its impact on the space sector from Mr. Jung-ho Park, Head of Research and Development Strategy Office of CARI. Mr. Park has been a senior researcher of the Research and Development Center in Madison, Co. He's been a researcher of policy analysis team in CARI, where he started his career. upwards. He became senior researcher of external relations and cooperation team in CARI. Afterward, a senior researcher of space policy team, and then head of policy coordination team in CARI as well, head of research strategy team, and actually he is the head of the research and development strategy office also in CARI. Please, the floor is yours.
Yeah. Hello, everyone. Thank you for inviting me here to meaningful workshop between Mexico and Korea. And I'm currently head of R&D strategy office of CARI. I'm very honored to be here to address about Korean space development plan and its impacts on the space sector. Yeah, these are my contents of my presentation. First, I will briefly introduce about background and history of our space development plan, and then I will introduce our current space development plan, the third space development page plan, and then I will briefly show you our achievements of last 30 years, and lastly, I will show you the impacts of R&D investment in space area. So, yeah, I will start background and history. Our space development plan, our national space development plan is Space Development Promotion Page Plan. We established this plan every 5 years in accordance with the article of the Space Development Promotion Act, which was established in 2005. Yeah, and the main purpose is to of this the plan is to establish the concrete space development plan for the next 5 years. I will show you briefly the history of our space development plan. In 1996, the mid to long-term plan for national space development was established. This is our first space development plan. And in 2007, our first space development promotion page plan was established. And now, 2018, the third space development promotion page plan was established. This year is the last year of this third space development promotion page plan. Our government is preparing the first space development promotion page plan. Next, please. Yeah. Yeah. Sorry. I will briefly introduce about our current space development plan. The vision is contribute to the national security and quality of life through challenging and reliable space development. And we have 4 goals: harmony of challenge and practical interest, and people's inspiration for space and science, and selection and focus on strategic area of the space area, and new industry and job creation on the space sector. Oh, sorry. For this vision and goal, we have for the long-term plan, establishment of Korean satellite navigation system until 2035, launch of asteroid sample return spacecraft, launch of small medium-sized satellite by industry-led development of government satellites. We have 6 strategies and 16 missions for our vision and goal. Let me introduce in detail about our strategies. Strategy 1 is acquire domestic launch capability. As you know, we developed an indigenous space launch vehicle capable of 1.5-ton class satellites into LEO. Actually, we performed the in-flight verification of 75-ton main engine last year in 2018, and last year we launched the first KSLV2. Unfortunately, we failed, but this year we successfully launched our KSLV2. And strategy 2 is the investment and diversification of satellite development and utilization. For disaster monitoring, we are providing emergency response and real-time supporting service. And ocean monitoring, we are providing periodic and high-resolution observation service for the sea area surrounding Korean Peninsula. And also for meteorology and environment, we set up monitoring system and provide all-time data service. And for agriculture, forest, water, we are servicing to the public for precise navigation information. And also for efficient system for satellite development and utilization. First, for satellite development, we set up national satellite development long-term plan, which includes systematic improvement of technology readiness level, research on breakthrough technology, and industrialization of satellite development. And for efficiency, we established efficient cooperation systems such as diffusion of technology to industry. And also we are developing core space components domestically, such as satellite payload, according to our space development, state space technology roadmap. And also the efficient space, the satellite utilization, we are conducting data analysis R&D and establishing a satellite information utilization infrastructure system. And also we are supporting users through diversifying the application areas and supporting a user community to create new scientific and market opportunity. And also we are trying to increase the satellite images export and support companies entering overseas market. Strategy 3 is starting space exploration. Korea is doing space exploration step by step. First, step 1 is development of KPLO. We will launch this August KPLO. And step 2, lunar lander will be launched when meeting the prerequisites. And step 3, asteroid sample return mission. And also we are securing strategic technologies for each exploration step. For example, precise positioning and navigation in deep space, and large capacity space propulsion, and so on. And also docking and re-entry technology. As you know, these days, the space debris and the problem and the space security are becoming more important. To advance our space surveillance, we established a national response system to monitor space risks and secure related technologies. And also we are securing capability of space surveillance and analysis. For example, ground-based space surveillance radar and small satellite technology for space surveillance. Also, we are carrying out various research on space exploration and science. Strategy 4 is establishment of Korean positioning system, KPS. With KPS, we want to strengthen national infrastructure and promoting industrial use of smart information.
In last years, Mexico has have tried to establish deals with your companies for ground communication systems for the space sector. At that time, we try really hard to get some products, some innovation in being together with the two countries, working to develop for the spacecraft for Mexico, specifically for Morelos 3. So I wonder, at that time, it couldn't be possible. The development of both sides were not feasible to release the product. At this time, I wonder, I can see the steps, the gigant leaps that you are taking, and the research and development. How mature is your industry in that way? How on based ground stations and based on ground communication from space to Earth are now seated? How strong is your industry at this time? In the future, Mexico is thinking of launching systems and doing things, and we really get impressed by two main things. One was, of course, optical. Your country is very good at that. And the other one that we were trying to reach is something to push together in the radio communications. So my main question is how you feel about that, how many companies are there? Thank you.
Yeah, I think it is a little difficult question for me, but I can some answer to you. So there are some startups in Korea in ground station area, and so they are doing their business and internationally, and also Korea has many technologies in ground system or ground stations. So I think we can find the collaboration area in those areas, and also maybe you can ask another our experts later. Thank you.
Thank you very much, Mr. Park. Since we have no more time for questions, we would like to give you an applause, please.
Thank you.
And I'm glad now and honored to introduce Maestro Carlos Duarte. He is electromechanical engineer from University of Mexico and Master in Scientific Instrumentation from the University of California in Santa Barbara. Recognized track record in developing and managing innovation projects in the academic, private, and government sectors. He is mentor of the space missions AztecSat-1, Atlacom-1, Mission Colibri, and the AztecSat constellation. He is now head of the Latin American Nanosatellite Project. He is a full member of the Mexican Academy of Informatics, a collaborator of Hacia el Espacio, the Mexican Space Agency Outreach Magazine, and writer of the column Era Espacial at A21, a leading aerospace news website presently. Mr. Duarte is the Deputy Director General for Human Capital Development at the Mexican Space Agency. Please, Mr. Duarte. The floor is yours.
Thank you very much, Mario. I'm very pleased to be here, and I thank Kari for this effort that has been doing to promote and organize this workshop in conjunction with the Mexican Space Agency. I hope that we're going to have a lot of good results out of this workshop, and hopefully develop some projects with our Korean friends in space technology. So the objective of my talk is to describe some of the small satellite projects developed in Mexico in the recent years. And also offer the capabilities of Mexico for developing small satellites. So Mexico has been in the space field since a long time ago, but not just since recently, let's say 5 years, that we started developing our own satellite projects. And we started with nano-satellite projects, mostly university projects. So that's a very humble beginning, but the good news is that we are developing very rapidly. So we hope that in the future we will follow the example of our Korean friends, and hopefully with the cooperation with Korea, we can achieve the results that Korea is now achieving in space development. So I'm going to go very fast in my presentation since I have to cover a lot of things. Just, I'm going to start with a review of what are small satellites. Everybody knows what are small satellites, but I'm just going to talk about what precisely I'm going to talk today here. I'm going to talk also about the design cycle of small satellites, which is one of the subjects that we want to master in Mexico. This cycle of designing small satellites, and then we're going to describe some of the projects that we have developed in Mexico as a country. These projects are not only developed by the Mexican Space Agency. These projects are developed mostly by universities in Mexico. So that's I want to point out. Although the Mexican Space Agency has been involved in some of these projects. And finally, after describing these projects, I'm going to draw some conclusions. So, well, everybody knows what are small satellites. The classification is not very clear. We talk about mini satellites, where the weight of the satellite is around 100 kilograms. Then, whoops, something happened. Then microsatellites, and then nanosatellites, where we're talking about satellites. Nanosatellites, we're talking about satellites in the range of 1 kilogram to, let's say, 10 kilograms. Those are the satellites that were being developed in Mexico right now by our own means. This is different from the previous generation of satellites that we bought for communications. Mexico has a long story of having space objects in the geostationary orbit, but those satellites were bought from foreign companies. Something is not going well here. Okay, so next, please. Could you please, just a second. Okay, next, please. Yeah, just to have like a background, I'm going to talk about the life cycle of a space project. Since this is very important to master, because in Mexico, in the past there were many organizations that had capabilities in developing space subsystems, but not in the whole cycle. And this is very important, and our Korean friends will agree with me that one of the very important things to master in designing space projects is knowing the overall cycle, because there's a lot of subtleties in the cycle, and there are many things that are not necessarily technical, which are, for instance, regulatory aspects that we have to deal with. So we start with the mission definition, then with the mission design, then integration and testing, then launch, operations, and closure. And this is a cycle that repeats itself, is iterative, and every time we go through this cycle, we make a better design. Next, please. Well, so there's some. Now, what are the Mexican capabilities for designing small satellites? Well, first of all is human capital. We have many universities and research centers in Mexico dedicated to space and aerospace technology. Those are located in all over the country. I can mention one of the main universities is UNAM, the National University of Mexico, and also the National Polytechnic Institute. Those are like the main institutions in Mexico dedicated to aerospace and space technology. But there's some other institutions like CICESE in the northwest part of the country that has very fine human capital development. UPAEP, the popular autonomous university of the state of Puebla, which designed and constructed the Aztec-1 satellite, Universidad Panamericana, and some others that are gaining a lot of experience and are developing a lot of human capital. I can mention also, for instance, CETIS Universidad, which is located in Mexicali, in the northwest part of Mexico, which is right now developing a nanosatellite in conjunction with the University of Arizona. So you know, we have these capabilities. Also, besides human capital, as Dr. Landeros mentioned in his talk, we have 2 space centers in Mexico. One is located in the state of Zacatecas, west of Mexico City, which is dedicated to satellite communications. And there's another center located in the city of Tlacomulco, a 2-hour drive from here in the state of Mexico, which is dedicated to nanosatellite design, small satellite design. So those are 2 very important assets that we have in Mexico for developing satellites. Next, please. Let me see. Besides these centers, we have testing capabilities in Mexico, and these testing capabilities are located in several of the universities, Mexican universities. For instance, IPN has the most complete environmental testing capabilities in Mexico. IPN has vibration testing capabilities, thermo vacuum capabilities, and anechoic chambers. This is very important for the development of small satellites. But I can mention other institutions in Mexico, like UNAM, the Advanced Technology Center of UNAM, located in the state of Querétaro. Also the Center for Nuclear Studies in UNAM, the Institute of Nuclear Sciences in UNAM. They have very good capabilities, and for instance, this institute is the one that is developing the mission to the moon that Dr. Landeros mentioned in his talk. And also, I can mention the University of Colima, which has an anechoic chamber. So all these capabilities make Mexico self-sufficient in the design, development, testing of small satellites, of nanosatellites. Okay, I'm going to start now describing the nanosatellite projects being developed in the past 5 years. I will start with Painani 1 and 2. These are 2 nanosatellites that were developed for the Mexican armed forces, for the military. These 2 satellites are operating, and their mission is mostly educational. They have a small camera that takes pictures of Mexico. These are 3-unit CubeSats, and they were developed by a consortium of Mexican universities for the Mexican Defense Ministry, headed by Instituto Politécnico Nacional, for the National Polytechnic Institute, but there were other universities involved, like UNAM, like CICESE, and some others. This is a very important project because the complete project was developed in Mexico. All these subsystems were developed in Mexico. So that is very good news for us because that shows that Mexico has the capabilities of sending subsystems to space, and all these systems work, all the communications, the onboard computer, etc., work perfectly. This other project that also Dr. Landeros mentioned is the Aztec-1 project. It was developed by a team of students and professors from the UPAEP, which is the Autonomous Popular University of the State of Puebla. It was a technology demonstration, and it was a joint project with NASA. This is very important because we had the help of NASA in this project. NASA was involved in mentoring the students and the professors that developed this project. There were around 80 people involved in the development of this project, and also NASA provided the environmental testing at their facilities. So this is very important because through this project, around 60 Mexican students were trained in the development of nanosatellites, and now these students are the seed for the next generation of satellites in Mexico. The other project is the Nano Connect 2. This is a project developed by UNAM. It's a 2-unit CubeSat. Also was developed by a team of students and professors of the Instituto de Ciencias Nucleares, the Nuclear Sciences Institute of UNAM. It was another technology demonstration, and was also a private company, an American company, involved in these projects. It was successfully launched from India through ISRO, and it was a very successful mission. This is another project, the D2 Atlacom 1. This is a 6-unit CubeSat that was not developed in Mexico, I have to point out. It was developed by a consortium of international consortium, including the company, the American company Nano Avionics, Dragonfly Space from South Africa, and some Mexican universities. But this project was developed in Nano Avionics. It was a technology demonstration that was intended to test a hyperspectral camera developed in South Africa by this company, Dragonfly Space, and also radios and propulsion system. And the project is in operation right now and is providing images for research projects in precision agriculture. So this is a very good example of international cooperation in the development of satellites in Mexico. Other project, this is not operating right now, it's in construction, is the project Ziva. I don't know if I pronounced it okay. It's a 1-unit CubeSat that has been developed by professors and students of UPAEP, the university that developed the Aztec-1. Now they have the capabilities and the experience to develop their own satellites. Its mission is an Earth observation mission for volcano monitoring. Particularly, they are going to observe the volcanoes in Mexico, the ashes, and with a camera, and to determine their the risks. This project is going to be launched by JAXA probably next year or in 2024. By the way, this project won a contest, the Kibo Cube contest, promoted by United Nations and JAXA, and they won this contest, and the prize was the capability of launching the system through a JAXA rocket. So the launch of these nanosatellites short, and I'm sure it's going to be also a success for Mexico and for Mexican universities. Another project is the COTO project. It's a one-unit CubeSat. It's being developed by a team of students and professors of UNAM, of the Center for Advanced Technology in Querétaro. The mission is also a technology demonstrations and will be launched in JAXA. It is also, this is very important because it was developed also by a team of professors and students, which is the trend in Mexico for developing CubeSats. Another project yet is the Colibri mission. This is a very ambitious project being developed. It's a 3-unit CubeSat. The satellite is called PACAL. And the mission is the measurement of the density of the high atmosphere through a very interesting process. It's hard to explain, but they're going to measure the drag of the atmospheric, of the high atmosphere, and then by measuring the drag, they are going to calculate the density of the high atmosphere, knowing the velocity. And this is a very interesting project because it has the participation of MIT and JPL and another companies. It's being developed by a team of students and professors of Universidad Panamericana. This project is already completed the design. They are in the process of developing the system, and hopefully it's going to be launched in 1 year and a half. Another project, this is also in process, is not completed yet, actually is in the beginning phases, is the Aztec-SAT constellation that Dr. Landeros mentioned also to you. It's a constellation of at least 4 nanosatellites that is being developed by a team of students and professors of several Mexican universities, including UNAM, the National University of Mexico, UNAC, the Aeronautic University in Querétaro, the Polytechnic University in Querétaro, UPAEP, and Universidad Panamericana, the Pan American University. So these 5 universities are going to develop this constellation of for at least 4 satellites. The mission is animal telemetry. So this satellite is going to be receiving signals from animals on the ocean, on the surface of the ocean, and to locate the animals and determine their migration patterns, and also it's going to be used for Earth observation, because these animals have instruments that are measuring continuously oceanographic and atmospheric parameters like salinity, like acidity, like temperature, and with this information, there are going to be some research related to climate change. The project is also a joint project between the Mexican Space Agency and NASA. NASA, where this project is being developed for an organization in the United States called the BOEM, the Bureau of Environmental Monitoring, which is in charge of monitoring these animals in the surface of the ocean. So the project is in the beginning phases. The mission has been determined, and we hope to have the constellation ready in a couple of years. The participants, as I mentioned, are these universities: UPAEP, UNAC, UPQ, Universidad Panamericana, and also there's the participation of Mexican industry. Mexican industry is interested in participation of this company, this project. I'm not going to elaborate on this. This is the project work breakdown structure. What I want to show here is that the participation of the university is going to be centered in different subsystems. So the way this project is going to work is that every university is going to work in a specific or several specific subsystems, and then there's going to be just one design, and once that the design is completed and validated, there's going the university is going to construct at least 4 nanosatellites. That the number of satellites will depend on the funding, but we have to assure that the constellation has at least 4 nanosatellites. Well, just to conclude, my conclusion is that you know, we are, since even that we started not very late in the development of nanosatellites, we are going very fast, because you know, we started with just 1 nanosatellite, the Aztec-1, and now you see that we have a constellation and at least 6 more projects, and that's just in a period of 2 years. So this trend, if this trend goes in the same way, we will have in a couple of years a very impressive university system in terms of developing small satellites. That's because we have very good human capital, design centers, testing capabilities, but most important, we have a proven methodology to develop this system. This is, I mean, like the glue, the methodologies that makes these projects successful. Without the methodology to developing a space project, I mean, what you will have is just isolated subsystems, but not a complete project. These capabilities are being transferred to industry. Hopefully, we have now several small companies interested in developing their own systems. So, through the Mexican Space Agency, we are transferring these capabilities to industry. And our ambition is to scale these capabilities and develop larger satellites in the future, hopefully with the help of our friends from Korea. And with this, I end my talk. My final slide refers to an invitation. We are organizing the 3rd conference on space activities from August the 31st to September the 2nd in the city of Aguascalientes. So we already published a call for papers, and that's going to be a very, very important event for the Mexican community. So I hope everybody here could join us in Aguascalientes on August 31st to September 2nd. Thank you very much.
Thank you very much, Maestro Duarte. If there are any questions, please. 1, 2. Please.
Okay, you said some of your CubeSats are going to be placed into orbit by JAXA. Does that mean you bought the launch service from JAXA, or you have some kind of other kind of cooperation to put your CubeSat into orbit by JAXA?
No, at this moment, we just have this the launch service that JAXA is going to provide to this particular nanosatellite, Xiva, because the university won a contest, an international contest, and the prize was launching the satellite. We are actually, we're going to have talks with JAXA. We have some, so we have, in the past, we have some talks with JAXA, but we haven't developed any project right now, any joint project with NASA, with JAXA. This is an isolated event where this university is going to send their satellite through a JAXA rocket.
Other question?
Gracias. It may not be a question, just talking about the constellations, the nanosatellites, talking about as principal of University, Polytechnical University of Querétaro. I want to thank all the AM, because this represents a new challenge for our students, for our teachers to be part of this new industry. And in Querétaro, I think we take the challenge and we want to be the part with you in all this development as we are doing so far. So thanks to you.
Thank you very much. Yes, I mean, the idea of these projects involving universities is to spread the knowledge of space development among students and professors. That's very important, the involvement of professors. And we were very lucky because we have NASA in this project, and NASA has been very good at sharing their methodology with us. Okay. They keep no secrets. They're very open with us. The guidance of NASA has been very important for the development of Aztec 1, and is going to be very important for the development of this constellation. And we hope to have these kind of cooperations, not only with NASA, but with all other space agencies like CARI. But that's key. The international cooperation is key for the development of the space sector in Mexico. Another question?
Another question, please.
Sí, tiempo.
Thank you for your talk. I have just one question. I would like to know, in your opinion, why the Mexican industry is so limited in this kind of projects.
Yeah. We are at the Mexican Space Agency. We have one area dedicated to this linking with industry, and we want the Mexican industry to be involved in these projects, particularly in the AztecSat constellation. We invited FEMIA, which is the Mexican Federation of the Aerospace Industry, and one of the companies of FEMIA is going to participate in this project. Is going to put money. The thing with the space industry is that there's not much industry in Mexico. There's not much space industry in Mexico. Most of the industry in Mexico related to aerospace is aeronautical. So our ambition is to develop more space companies in Mexico, and that's why we invite students and other companies to get involved in the space industry. Today we are going to see a talk by the head of a company in Mexico, Space Zero Gravity, which is a company that is interested in developing nanosatellites in Mexico. And this is fabulous for us, because if we wish this company a lot of success, and we wish that this example to multiply all over Mexico. There's a lot of talent, but still the Mexican space industry is very small.
There is no more time for questions, I'm sorry, and please a big applause for Maestro Duarte. And next, I have the honor to introduce for the next talk from CARI, Technology and Commercialization, Mrs. Hee Jin Bai. She's the head of Technology Commercialization Office of CARI. She owns a master's degree in electronic engineering from Korea University, and previously a bachelor's degree of electronic engineering also from Korea University. He has been working as a head of technology commercialization office in CARI, as well as a senior research of mission operation and infrastructure service division in CARI, and actually research of Information Technology Center, Samsung Electronics, previously. Please, the floor is yours. It's the two of you, sorry. Mrs. Yusung Won, she's a senior researcher of Technology Commercialization Office in CARI. Her actual position as a senior researcher of Technology Commercialization Office in CARI. She owns a Doctor of Philosophy in the field of School of Electrical Engineering in Korea, Advanced Institute of Science and Technology, KAIST. As a work experience from December 2021, she is the senior researcher of technology commercialization sector in CARI, previously examiner of measurement technology team, and as well as a senior researcher of smart vehicle research section in Este. Please, the floor is yours.
Hello, I would like to thank you for giving me this workshop to introduce CARI technology and commercialization. I'm Hee-jin Bae and head of Technology Commercialization Office. This is Yusun Won, and she is in charge of technology transfer in Technology Commercialization Office. Now I'll start my presentation. This presentation consists of 4 parts. The first would be introduction of Technology Commercialization Office in CARI. Second, I will show you CARI's technology and some patents. And in third part, Dr. Won will show you technology transfer. Technology Commercialization Office supports several companies in aerospace, so we'll introduce some companies in the rest part. Let's move to Technology Commercialization Office. This is diagram for roles and responsibilities of IP patent, IP management. IP, that's to say patent and copyright and so on, is the result of aerospace R&D. We manage this IP, and then we try to transfer technologies to company by technology marketing for technology commercialization. Sometimes we can also transfer technologies to universities for technical cooperation. SME is small and medium-sized enterprise. CARI is governmental research institute, so we have responsibilities to support to improve commercialization for related companies such as SME and startup. Now I describe the CARI's technology. CARI's technology can be divided into 4 broad groups, like as aeronautical technology, satellite application technology, satellite technology, and launch vehicle technology. You can get more detailed information from CARI's experts in this workshop. This is English CARI website. If you can contact the web page with the website address, you can find international cooperation. You can select CARI technology and you can see development and application like this. Now, as you can see, this is development section of CARI technology. If you click any part, you can see the technology list and download the PDF files for the technology SMK. SMK is sales material kits and mainly used as marketing for technology transfer. Application section is also worked similar to development section. If you click any part, you can see the technology list and download the PDF files for the technology SMK. This is patent application status by research field in CARI. This is a diagram. This is patent application status by research field in CARI. This is a diagram in the number of patent applications. Total number of patents in CARI is 1216 at the present. You can see 0.5% of patents concentrated on space technology, including satellite and satellite image application in the diagram. As I think Korea and Mexico can be expected to cooperate more in space technology field. This is example of CARI patent list. And now Dr. Won will present for technology transfer.
I gave a presentation about technology transfer of CARI. Technology transfer and licensing refers to transferring technology or granting a license to a company who wants to perform intellectual property rights or technologies. There are various forms of technology transfer as follows, and we mainly do technology transferring and granting a license. CARI's experts try to create and improve aerospace technologies in Korea. Therefore, the Technology Commercialization Office carries out technology transfer and licensing in order to increase the utilization rate of CARI's excellent technology. These are CARI's representative R&D achievements in the field of satellite, launch vehicle, and aeronautical technologies. We disclose information about the technologies which have been achieved or are expected to be transferred on our website. So you can get specific information about CARI's technologies on our website. This slide shows CARI's technology transfer process. This slide shows the technology transfer or licensing status as of May 31st. There are 110 valid technology transfer or licensing contracts, 88% with small and medium-sized enterprises, 5% with large enterprises, and 7% with other organizations, including universities. These results indicate that cooperation with SME in the aerospace field is very important, and supporting SME is one of our important roles as a government-funded research institute. Meanwhile, breaking down the valid contracts by technology sector, satellite and application technology accounts for 51%, aeronautical technology accounts for 34%, and launch vehicle technology accounts for 15%. It is expected that technology transfer will increase further in relation to KSAV2 and KPLO. These are the results of a commercialization survey we conducted this year. After the technology transfer from CARI, 65 companies responded to the commercialization survey. Among 65 companies, 14 companies succeeded in commercialization, 34 companies are in the process of commercialization, and 17 companies gave up or stopped commercialization due to their circumstance. In summary, 74% of 65 companies said that the technology transfer or licensing from CARI helped them commercialize technologies. In addition to technology transfer, we are supporting many companies in the aerospace field with our various roles and responsibilities. In Korea, industrial ecosystem in the aerospace field consists of CARI and related companies. Among these related companies, Hancom in Space, Telepix, Soltap, and Cetrec will give presentation in this workshop tomorrow at 3 p.m. Especially the CEOs of Contact, Narma, and Hancom in Space are those who worked as researchers at CARI. A few years ago, they made big decisions to stop their career at CARI and took on the challenge of starting up new companies. We ask for your understanding that the CEOs of Contact and Narma wanted to participate in this workshop, but they are unable to attend this workshop due to other schedules. So my boss will introduce Contact and Narma instead of their CEOs.
Thank you, Dr. Won. First, this is Contact's story. In order to be the leader of global space market, Contact established a partnership with global government and commercial satellite operators. Level 1 is GSAAS. It supports all satellite and launch vehicles for data downlink and TT&C from Contact's ground stations. Contact implemented the first commercial ground station in Jeju, South Korea, and started to provide the data platform service. Once the customer requests to receive the data, Contact's ground station is scheduled for a pass and collects the data when the customer satellite passes over the pre-scheduled ground station. Contact then further pre-process the data and utilize it for analysis services. The station currently supports SX, VHF, and UHF frequency bands, and will soon support Ka and Ku band. To extend the coverage, Contact is establishing a government network of ground stations in 12 sites and 10 different countries. Contact will also deploy telescope observations to develop SSA solution in order to ensure safe operation of satellite. It will also deploy optical ground station to strengthen the efficiency of space-to-ground communication. Contact starts its ground station business officially in June 2020. Its major customers include global private satellite operators such as Planet and ISI and KAIST and other universities and entities from South Korea. The company reached a success rate of 99.5% with about 10,000 passes a month. It also cooperates with other ground station service providers to access to wider customer range and offer more convenience. Level 2 is satellite image preprocessing. Contact corrects the noise and spatial distortion of the raw imagery by performing radiometric, geometric, and spatial correction using algorithms customized according to customers' satellite specification. Contact has been engaged in a joint R&D project with CARI for COMSAT 3 through A, CAS 501 systems, and COMSAT 7 system is currently in progress. Contact is also developing a pre-processing system for EO and SAR satellite to be launched in the future, including COMSAT 7A, CAS 502 and 4, and EO and SAR nanosatellites, government defense satellites, etc. Next level is satellite image application. Based on deep learning, contact analyze change the N specific object within satellite images to detect changes, monitor disaster, monitor illegal buildings. Contact has been working in B2G and B2B business for government agencies, corporations. Since last year, its application solutions for over-city management is provided to Sejong Smart City in South Korea. One of Contact's future plans are B2C service to sell satellite images to individuals. Cytocurrency and NFT non-fungible tokens are biggest trends recently. Contact plans to introduce an initiative NFT product using satellite images to the market. Satellite imagery can be a good source to help students practice block coding by finding routes and buildings within the imagery. Contact started space education business in Luxembourg and is preparing some educational programs. In addition, Contact is planning to cooperate with the galleries to make satellite imageries into artworks. This is a brief introduction video of Contact. Let's see it together.
Please press the button to play video.
"50 years have passed since mankind made an extraordinary attempt, and now space has become a reality, not a dream. And the era of new space has started. The space industry, which used to be operated by the state, has now shifted over to private companies such as SpaceX. And with the miniaturization and standardization of satellite components, small to micro satellites are rapidly being launched for commercial purposes. Even as we speak, there are thousands of satellites in orbit that are constantly collecting and producing data which are received from ground stations on a daily basis. And we estimate that more than 40,000 small satellites will operate in space in the near future. A countless number of satellites will be launched from all over the world, and these satellites will be served with Contact's ground stations to provide more related services to the customers. Established in 2015, Contact is led by the CEO Sung-hee Lee, who worked in Cary for 16 years and has teams of experts with extensive experience in the space industry, including satellite launches, satellite control and operation, and satellite image processing. With these professionals, Contact is able to provide all solutions required downstream. Based on the experience of in-house development and operation of related software and hardware, we provide a wide range of services from the ground station data receiving, satellite image pre-processing, and to the satellite image application. All services offered by Contact have been developed as a web platform, which provides excellent security and a user-friendly interface. Furthermore, by establishing the first privately owned commercial ground station in Jeju Island in 2020, Contact became the only service provider of satellite data reception and transmission in Korea. With such excellent technology and experience, we get continuous inquiries from global companies in the US, Sweden, Japan, and more. And we possess IPRs for technology related to ground station and image processing services. In order to satisfy the rapidly increasing demand for satellite data application, Contact categorizes the service model into 3 levels to meet the user's needs. First, we receive a request for satellite data from a satellite operator. Then, Every time a satellite passes over the addressable reception range of Context ground stations, we receive the data and deliver it to the satellite operator. Such receiving service from ground station is provided on a web platform to deliver the collected data to the customer. During this stage, we can perform pre-processing of the received data by applying calibration and validation algorithms to correct any distortion in the image data. In addition, we can detect changes in a specific area and objects such as buildings and roads within the satellite image by applying deep learning algorithms. From this service, we can monitor unauthorized buildings in smart cities, detect changes in a city, analyze statistics, and more to provide the necessary information through our web-based satellite image application service platform. Contact plans to build the first commercial launch site in Asia and launch its own satellite to constantly supply and make use of satellite imagery. Moreover, Contact will focus on FSO technology, which enables flawless communication between satellites and ground stations, and beamforming array antennas for multiple satellite tracking, which will lay the foundation for the growth of local space industry. Contact's ultimate goal is to launch satellites made by Contact at Contact's commercial launch site and receive data through Contact's ground station and become the only space company in the world to provide a total one-stop solution. Thank you.
Then this is Narma's presentation. In the 1960s, the death rate per 100,000 people in large cities and rural areas was almost the same, but recently, the death rate in large cities is 13.5% lower. Pesticide poisoning in rural areas and the distance to emergency medical centers are the biggest reasons for this. The best way to solve this problem is to use drones to quickly deliver antidote, AED, first aid, medicine, etc. Narma, a spin-off company of Kari, developed in the world's first electric tiltrotor drone optical for delivery. This tiltrotor is capable of vertical takeoff and landing and high-speed horizontal flight at the same time, and has the capability to deliver 5 kilograms of payloads up to a distance 40 kilometers in 40 minutes. Drones for global delivery have been developed by Amazon, Google, and Wingcopter, but when considering the weight, wind resistance, and the price of the load that can be delivered, Narma tiltrotor is by far the best in the world. Germany's Wingcopter drone, which competes with Narma's tiltrotor drone, has 4 propellers instead, close to fuselage, and has excellent performance in cruise flight. However, it has a weak point in wind resistance during the transition from vertical takeoff to horizontal flight. Unlike existing drones that can only be operated by a specific pilot, Narma drone has the characteristic that it can be operated only with a simple operation device such as kiosk, and eliminates the manual controller so that everyone with pilot licenses can operate it. In order to reduce manufacturing cost, Narma introduced a new technique of prefabricating carbon plate rather than the manual molding technique using a mold, which is significantly reduced manufacturing time and cost. Because delivery with today's expensive drones is difficult to compete with delivery of cars or motorcycles. Infrastructure and transport and flew between buildings in a non-visible flight. For overseas expansion, Narma planned to fly in South Africa, Croatia, Ethiopia, and Philippines this year. In particular, the company plans to start a full-scale drone delivery service by signing an MOU with Korea's largest convenience store CU in the field of drone delivery. In addition, Narma is developing a hydrogen fuel cell drone to further extend its flight range, and it aims to complete the development of a tilt-rotor capable of developing 20 kilograms of payloads by 2025. Last, Hancom Space Story can be presented at section 19 by Dr. Choi at tomorrow. If you are more interested in contact at Narma, you can contact with this email address. Gracias.
Thank you very much, Dr. Yusung Won and Master Hei Jin Bei. Any questions? Master?
Thank you very much. Very impressive presentation on those two companies. And my question is, what kind of services or activities do you foster or provide for startup companies in Korea through your institute? You mentioned that at the Technology Transfer Office, you provide services for startup companies. So what are those services? How do you promote the development of new companies in space in Korea?
We support some kind of marketing. Yeah. Incubating system is only for startup by Kari researcher, only for Kari researcher. Yeah. Yeah.
Thank you very much. Here is another question.
Yes, thank you for the presentation, first of all. And I have a few questions, but I'm not going to do all of them, just two of them. How do you develop the technology transfer with the universities? You mentioned that there are some cases, some examples in this topic. Could you give us some example of this with the universities?
The cases of university transfer contracts is very small, so it is only for developing research project, just project. So
only for research projects?
yes.
Sorry, we cannot remember. Sorry.
Don't worry.
Maybe about satellite satellite technology.
Okay, and another question, do you have any relationship with Latin American countries in this technology transfer process? For example, another colleague of Cari mentioned that there were 2 Latin American countries, I don't remember exactly which ones, but have you had a project of transfer technology with these countries?
In the broad in the broad view, maybe technology transfer process will be similar in the nation field. Yeah.
Okay, thank you very much.
Thank you very much. We have no time for more questions, and we would like to have a big applause for our presenters. And I'm happy to introduce now our next session, Applications on Earth Observation, from Dr. Adán Salazar, Mexican Space Agency. Dr. Salazar is the head of the Scientific Research and Space Technological Development in the Mexican Space Agency. He holds a doctorate in real-time computing, robotics, and automation from the Center for Applied Mathematics of the École des Mines de Paris and the INREA of Sophia Antipolis, France. He has experience conducting research and developing technology in computer vision. This includes camera calibration, 3D reconstruction, visual tracking, augmented reality, and image processing. Hello? Houston? He has some published papers in the area of remote sensing using satellite images from the Copernicus project of the European Space Agency, SPOT and Landsat. Among his most relevant works, we can mention his participation with a multidisciplinary group from Sinvestav Merida in detecting the arrival of floating sargassum on the coast of Quintana Roo using multispectral satellite images and machine learning techniques, as well as works to detect the subsidence induced in the terrestrial surface after an earthquake using synthetic aperture radar images. Please, Dr. Salazar, the floor is yours.
Thank you very much for the presentation, and thank you for being here, everybody. Good afternoon. I am very glad to be here and present a little bit what the Mexican Space Agency is doing about, in the topic of Earth observation. I am going to present this outline of the presentation. I'm going to talk first to the Regional Centers for Space Development. A colleague of mine already talked about it, but I have to talk myself because I have to introduce this center because there are 2 assets of the Mexican Space Agency where we develop all the technology about satellites, small satellites, to some Earth observation application, and also we have a laboratory that is dedicated to image processing satellites. So the next topic we'll talk is this laboratory, that is our main laboratory to processing images. And then I will talk about application that we are already are doing in this laboratory. By myself, I am leading this project in the Mexican Space Agency, and together with some institutions from France, we are working in this project, and I will show what it has been done by myself in the past, and what is the next step that we are going to develop. So next, I will talk about the Mexican Observatory for Climate and Atmospheric Composition, that is called OMECA in Spanish. This is a laboratory, that is a mobile laboratory that we are going to put in the south of Mexico to monitoring the carbon gases and how they impact due to human activity. And the last topic that I will show to you is the satellite Internet of Things. That is is an application that we are already running in the Mexican Space Agency, and how some images and some analyzed optical images will give information to this project, and together make an analytics and results to precision agriculture. Okay, so I will start with the centers. The Regional Centers for Space Development. We in the Mexican Space Agency, we have two centers. One is located in the state of Mexico, in Atlacomulco, and there we have this is located in the city of Atlacomulco, that is 130 kilometers away from Mexico City. It's about two hours. And in this center, we can see, maybe so it's far for some of you, but we can see the facilities that we have there and some activities that we have. The facilities that this center has is the administrative area, auditorium, activity classroom, clean room to integrate satellites, offices like human capital formation and technological transfer. Also, we have laboratories, and that's why I have to talk about. We have a laboratory that is a nanosatellite design and development laboratory. That is there we have all the expertise to integrate satellites, telecommunication satellites, and also we can design and integrate Earth observation satellites, a small one satellite 136E unit. Okay. Also, we have a rocket design laboratory. This laboratory is only using in the concept and the design in software using tools like ANSYS or SolidWorks, but we don't have the tools or the machines to build physically the rockets. But we can design and provide some knowledge to other institutions. But in the future we are going to have this machine to build over rockets. Okay. And finally, we have the digital image processing lab. That is a lab that is entirely reserved and dedicated to Earth observation, satellite image processing, and the services that we want to provide. The next center is a center that we have in Zacatecas, the state of Zacatecas, that is located in the city of Zacatecas, Mexico. It's 600 kilometers away from Mexico City. Here in the map, we can see two markets, and where is the red one in the center of Mexico, there is Zacatecas. It's just on the middle of Mexico. And in this center, we develop more the telecommunications, because we cannot imagine some air observation, satellite observation without communication, because we need to download the images or upload the commands to control and the telemetry of satellites. Okay, so there is more dedicated to telecommunications, ground station, develop and design ground stations, and we have facilities like administrative area, auditorium, active classroom, and you can see the images of activities on these facilities, offices for researchers, and laboratories. The laboratories are more to communication, that like space instrumentation and signal processing, modeling and system simulation for space telecommunication, electronic design, and embedded system for space telecom. This laboratory is developing some small cards to process the images, to give a pre-processing of the images. Okay? Also, we had the integration and testing of space systems, software-defined radio and IoT for satellite, antennas and RF devices, and also autonomous vehicles and robotics, like those on the top right, we have a rover. And this laboratory and this center, I want to clarify that both centers, we are having some agreements with educational institutions and also private companies. In the case of Zacatecas, we depend a lot of the technology and also the knowledge of the researchers from the University of Zacatecas. Okay, so those are the centers of the Mexican Space Agency, and I hope you are very welcome to come to visit and also to make some collaboration with us and use the facilities, integrate satellites, or do any project that we can develop together. Okay, now I'm going to talk about the digital image processing laboratory that is applied for Earth observation. This lab, we can see here the facilities is inside of the Regional Center for Space in Zacatecas. We call CREDES. The acronym is CREDES. CREDES State of Mexico, CREDES State of Zacatecas. Okay, this is the lab. In the image, you can see the lab. We have 24 space with computers that are very robust computers to make this application of image processing, air observation, and the services that we want to provide. You know, this laboratory is aimed to provide services to national, international, government, and private institutions. So also we generate products with added value for satellite images, as well advisory and training services. Okay, and the images that we use come from satellites like Landsat, Sentinel, MODIS, and GOES. Also by commercial satellites like Geosat and GeoEye. Also, we download these images from free sites like NASA, ESA, USGS, NOAA, or also from ground stations that we have in Mexico, like Bismarck, that is from the Marine Mexican Navy, the military, and also from land node that is in the UNAM, the University of Mexico, or in the YMX, in the state of Mexico, the other university, that we have also agreements with them. Or we ask directly from some private companies like Thruster Unlimited that we have agreements. So all these images and data use like the input to provide our service and give some added value to these images. The services that we want to provide, as I already say, is like digital elevation models, heat source detection, urban areas changes, urban and rural cadastry, mineral prospecting, precision agriculture, hurricane monitoring, volcano monitoring, land use and vegetation, earthquake analysis, flood analysis, and detection in the forest area, because we are really interested about natural phenomena and natural resources. The earthquake analysis in this image in the bottom left, it is an image that I made with when I was in Centro Geo. It is about the earthquake that we have in Mexico in 2017, September. You can see the red areas is where the Mexico City subsidence or the motion, the movement of the city was bigger. The biggest motion in red or orange one, and the red and the green one are the less motion in this case. Okay. What about sargassum detection? As I say, it's a problem that I am very interested at. I also work 3 years back about this problem with Simvestab and SIPNOR in La Paz, Baja California. And I have experience to be in France with IRISA. It's an institute of research there. And the foreign institution, we work about sargassum and make a proposal to detect sargassum very easy. But the next step is to use CNN convolutional neural network. Okay, it's machine learning. This application I will show you is using in the supervised classification, but we are going to make more. We are developing another algorithm. Okay, but just now I am just working with IRISA and MIO. MIO is an oceanographic institute from France. We apply for budget in ANR, the Agence Nationale de Recherche in France, to develop this because they are also interested about the Caribbean because France has some territories there. And also we, like in Mexico and Mexican Association, we are interested about these arrivals in the coast of Quintana Roo in Mexico. I'm going to show what has been done and how this data I will take it to develop the new algorithm. So we have here the sargassum. If we have been in Cancun lately, we can think that it's a huge problem, right? And it is a huge problem when sargassum arrives to the coast. But many of us, we don't know that sargassum was always there. It's a natural phenomenon in the earth. Okay, so the problem is when it's growing uncontrolled and arrives to the coast. That is the problem. Yeah. So here we describe what is sargassum. It's a habitat that provides food, refuge, and breeding for so many animals. See, like fishes, turtles, marine bird, and has habitat. We need that sargassum be there, but the problem is when they arrive. So we have to detect or follow, tracking the sargassum to see and try to predict where is arriving offshore of in the coast. So we want to, with the some satellite images, like I'm going to present Sentinel-2 images. I detect sargassum, use the detection. But now, as I say, the new algorithm with this institution, we want to predict sargassum, including more information like marine currents, more satellite data, and also take all the information in the past and try to provide, to feed the algorithm, the machine learning algorithm, to predict sargassum, and has one application that is very robust and is going to predict very well the location of sargassum. And why we want to do this? Because you see here, I show you the sargassum invasion or arrivals around the world. You can see there in China, and also in France, and the last one is Antilles, France, and the last is also in France, on the north of France. And the big image is in Puerto Morelos, Mexico. It's in the Quintana Roo coast of Mexico. You see, that image is from 2015. But if you go to Cancun in this time, in summer, you will see some similar pictures, and you will take the pictures of your vacation like this. And this is the Yucatan Peninsula, and the part of the Puerto Morelos where we collect the data, and also we analyze for detection of sargassum on the open sea. Okay, so why we want to know this, and why we want to tackle down this problem is because if we track well sargassum, we can see what is the behavior of sargassum, and once we know this behavior, we can gather the sargassum before it arrives to the coast. Yeah? We can go together. Also, this information will allow us to put some barriers against sargassum before they arrive to the coast. See, in the right side of the image, I show some barriers. Also, we can reactivate. Once that we can control this phenomenon, we can reactivate the tourism activity like Cancun or the Antilles in France, okay, all the Caribbean. So what was asked to do in this project was to detect sargassum. So I decided to use a supervised classification. Sorry for the that the words are cut, but I think it's a problem of the display of the presentation. Okay, my presentation was well done. Sorry. So okay, so I decided to use a supervised classification from a software that is called QGIS. It's a quantum geographic information system. It's an open source. I try always to use open source software. I don't like to pay licenses. So I use QGIS, and inside QGIS there is a SCP, semi-automatic classification plugin, and this is a supervised classification. So here I show image graph that show 3 spectral ranges: the green, the pink, and blue. What is that? Is imagine that you want to classify three different patterns or 3 different classes. Okay, so you take a pixel from the image, and like in this case, it's a multispectral image. So you will see a spectral. Depends on how many bands is the data that you are using. And you will see the range of the spectra. So if you click in one class, for example, water, you will see a graph or a curve that will represent the water. Then you click another pixel that you see sargassum, you will see the spectrum of sargassum, okay? That is very different from the water. And if you take another pixel that it either sargasso or water, you will see another spectrum. So this, you have to collect many samples of these classes to provide, to feed the algorithm. And then you can ask, after training this algorithm, like this is sargassum, this is sargassum, this is water, 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 then you will be able to separate or classify what is from sargassum from water. Okay, so this plugin works like this. Then taking a Sentinel-2 images, I use I make a zoom in a small part of the image, that blue one, and there you can see a spot of sargassum. Yeah. So using some index like NDVE index, or another one like a 5 floating algae index, you can in the beginning, the first step, you can highlight the sargassum because it's kind of a plant, it's vegetation, so you can highlight. But it is not enough to classify all the sargassum, so that's why you need a machine learning algorithm. But this gives you information to feed the training algorithm, okay? So I use the NDVI to provide the input data to train my algorithm, okay? Then I ask, and here in the bottom left, you can see in the circle, in the blue one circle, you can see in red the spot of sargassum that I choose to a pixel to show the graph, the spectrum of sargassum. It looks like this. I add another layer to the information that it comes from the NDVI, and this data I use it to train the algorithm. Okay. Once that I did, I told you this is a really easy algorithm. Okay. Now we are developing NNA algorithm with more data. So I train the algorithm, and once that the algorithm is trained, I take one image, the left one, from Sentinel, yeah, and this image I apply the training algorithm, and the output you see is in red is the sargassum that was present that day with that image in the coast of Quintana Roo. Okay. And once that we have all the pixels, we can estimate how many sargassum, the area of sargassum we have, because Sentinel-2 in that case the resolution was 10 meters. Okay. To go quickly, I do this job. I use these areas. I take some images. I have to go quickly because I have a few time to end the presentation. I have these images. I apply the algorithm, and there in the right side you can see the sargassum. That is a Earth observation application. Okay, the detection of sargassum, and we have that already in the Mexican Space Agency, and when we are developing another one. So the Mexican Observatory, I'm going to start quickly. There is a observatory that the agency is funding together with UNAM and INEC to the climate atmospheric composition is the observatory, and the objective of this is the carbon cycle research, atmospheric pollution, and also we want to make a state of the art of monitoring of a monitoring station in the south of Mexico, okay? Because we want to measure the carbon trace, evaluate the impacts to the human due to human activities like industry, urbanization, transport, and also identification of risk zones because this pollution problem, the greenhouse gases. Yeah. What is Omega? Omega will be a mobile laboratory with a 20-foot maritime container. Yeah, here on the bottom in the right, we can see the container that we will contain all these instruments. The instrument that is going to contain is a high-resolution infrared spectrometer, a Pandora spectrometer, a flux tower, and a soil and deposition measurement instrument. We are going to use also and validate the data that is provided by some satellites that are already orbiting on the Earth, like Tropomai from the Copernicus program, Sentinel-5P, and also the new satellite that is going to be launched in next year from NASA. All this data we are going to validate. We will have the observatory on the ground, and we are going to validate the data that is collecting from this satellite and other satellites. Also, we are going to integrate this data to some networks that are on the world, and like Global Atmosphere Watch, PNG, and La Red Ticon. All this data we are going to provide it and make open source data from this observatory. And we are going to put it in the peninsula, in Yucatan Peninsula, in an area that is a reserve, is a natural protected area that's called Calakmul. And in the green square, we say why we are going to put it there. Yeah. And it is because it's a large station and being located far from urban and development centers, and it's ideal to capture background condition of climate and atmospheric variability. That's why we are going to put it there, because many of you maybe will think, why not in Mexico City? But in Mexico City there are many pollutants, or some too much pollution that doesn't come from this activity that we want to monitor. Okay, we don't want to add noise, if you want to see it like this. The last project that we have in running is the satellite Internet of Things. There is a project that is about IoT, but in this project we want to, in the image laboratory, we want to add information in the first step, in the beginning, in the monitoring, and in the last one, in the 7. Yeah, they are monitoring all these physical variables with IoT, but they ask to the image processing lab internal in the Mexican Space Agency. They ask for to us to add some information that comes from optical or multispectral satellites. So in the beginning, we are going to compare the in situ data with the satellite. At the end, to the final results, we are going to mix all the information and provide analytics with this information to show the final results. The project is not, there are parallel projects. That one doesn't depend on the other one. It's just to add more information and provide a better understanding of the variables that are measured in this project. Okay, so with that, I finish my presentation, and those are the projects that we already have in the Mexican Space Agency running. Okay, thank you so much.
Thank you very much, Dr. Salazar. Now we have time for 1 or 2 questions only here.
Hi, thank you for the presentation. I have two questions. The first one is, you said you use open source or open data to train your algorithms. I think it might be different for each algorithm, but are you also, is the data set enough for you to get the results that you wanted, or are you using any data augmentation techniques or things like that?
Yeah, thank you for the question. Yeah, we use open source data, and it is not enough. But we have to stay in this path because we don't have money to buy the data that is going to give us more information and provide a better results.
Okay,
but
thank
we
you.
need different data.
Okay, thank you. And my second question is the sargassum case was very interesting. Is there any other case that you are looking at that you did not share in this presentation?
More than sargassum? Yeah, the same algorithm, I apply the same algorithm and also the new one that I am developing to estimate the growing of cities, for example, or to classify some patterns and identify very well, for example, cars or houses or whatever. Because once that you know how to train the algorithm and the neural network, you can classify several things.
Here we have another question.
Thank you for your presentation. What are the technical specifications of your image to sargassum detection? I mean, like the size or distance of the camera or kilometers per image?
Okay. In this case that I show, it was Sentinel-2. It's a optical satellite or multispectral satellite with two bands, and the resolution that I used was 10 meters per pixel in the ground, because Sentinel can provide you 60, 20, and 10 meters resolution. But with some image processing, you can resampling all the layers, the 12 layers that provide the Sentinel to 10 meters resolution. Okay. And Sentinel is orbiting in around 600 kilometers from the Earth.
Thank you very much for your presentation and for your questions. Now we have time for lunch, but before that, we would like to give a big applause to Dr. Salazar.
Thank you. Thank you so much.
Now we go for lunch. We have from now to 3 p.m. And I remind you that we have very interesting presentations in the afternoon. So thank you very much. session number 7, development of the Korea launch vehicle. I'm pleased to present Dr. Hwan Seok Choi, Vice President of CARI. Dr. Hwan Seok Choi was appointed Vice President of Korea Aerospace Research Institute, CARI, in March 2021. He was previously Director of Rocket Engine Development Division between 2020 and 2021, and Head of the Combustion Chamber Team from 2005 to 2020. In this position, he was responsible for the development of Korea Space Launch Vehicle, KSSLV-2. Hwan Seok Choi joined CARI in 1994 and has been involved in various development projects from Compact Sat-1 to Korea Sounding Rocket 3 and Korea Space Launch Vehicle, KSLV-1. Hwan Seok Choi studied aeronautical engineering at Seoul National University and received doctoral degree in mechanical engineering at Postec. He was awarded Order of Science and Technology Merit, Doyak Lip, for the successful launch of KSLV-1 in 2013, and commendation from Minister in 2003 and 2000 for the development of KSR-3 and COMSAT-1. Dr. Seok Choi, the floor is yours. Thank you.
Okay, thank you for your kind introduction. I think our distance is far enough, and we don't need to think about the virus infection, so I will take off my mask. Okay, good afternoon, everyone. I hope you had a good lunch. I'm Han Seok Choi, Vice President of CARI. Today, I will talk about the overview of Korean space launch vehicle development. In the last week, CARI has made meaningful progress in the field of space launch vehicle development. We are very proud of it, and also I am very happy to be here and to have a chance to introduce our achievement to our foreign colleagues, especially to the RCEP members. Okay, my presentation will cover these topics. I will begin with the Korean space launch vehicle development history. CARI has been established in 1989, and since then we started rocket researches. We started from the sounding rocket called KSR, and we advanced to the space launch vehicles called KSLV. As I mentioned just before, last week we have successful flight of KSLV-2 at the second flight test. And early next year, we are planning another flight with the next Set-2 satellite as its payload. And also, in 2030, we are planning to send a lunar lander with our next generation launch vehicle called KSLV-3. This slide shows the history of Korean space launch vehicle development. The first sounding rocket research program, KSR-1, was started from 1990s. KSR-1 and KSR-2 employed a solid propellant rocket engine, and the KSR-3 was our first liquid propulsion sounding rocket. Korean space launch vehicle development was initiated in 2002, and now we are currently working on the KSLV-2 program. I will briefly review the Korea sounding rocket development based on a solid rocket. KSR-1 was a single-stage sounding rocket, and the KSR-2 was a two-stage rocket. KSR-2 can be considered as a one-step advanced version of KSR-1. Here are some numbers you may be interested in, and the pictures of these rockets are on the right-hand side. Also, I will sorry. Also, I will briefly review Korea sounding rocket development based on this slide shows Korea sounding rocket based on liquid propulsion system. The rightmost picture shows the liquid rocket engine developed for this project. It was launched in 2002, about 20 years ago. I will explain a little bit detail about the KSR-3 rocket engine. It is a kerosene liquid oxygen engine operating in pressure-fed type and employed ablation cooling. It was just an entry-level liquid rocket engine. We used the silica phenolic composite nozzle, and this picture shows the mixing head of the engine. After a very short time of testing, we got the mixing head was severely injured by the high-frequency combustion instability problem, and we tried several remedies, but we failed. And we finally succeeded to install such a device, which is called baffles. Okay, from now on, I will introduce about our space launch vehicle programs. Korea has carried out two space launch vehicle programs, KSLV-1 and KSLV-2. The KSLV-1 is capable of delivering a 100 kilogram payload to low Earth orbit, and the KSLV-2 has the capability of delivering 1,500 kilogram payload to the low Earth orbit. What in the middle is the KSLV-2 TLV. Here, TLV means test launch vehicle. It consists of just the second stage of KSLV-2. It was just a single stage suborbital rocket for the in-flight test of the 75-ton liquid rocket engine developed for the first stage of KSLV-2. This table, as well as the right picture, compare both launch vehicles. Let's look at KSLV-1 in more detail. It was a two-stage space launch vehicle developed under international cooperation with a Russian partner, Khrushchev Space Research and Production Center. Its first stage was developed by Russian, and its upper stage was domestically developed by Korea. The propulsion system of first stage employed powerful Russian stage combustion cycle engine, whose vacuum thrust amounts to 210 tons. The second stage propulsion system employed our own solid rocket motor, whose vacuum thrust amounts to 8 tons. This slide includes several video clips acquired during the development of the upper stage for KSLV-1. You will see several test scenes in a sequence. The first one is the payload pairing separation test. Payload pairing is separated into two pieces by the action of separation mechanism. Next one scene is the upper stage reaction control system test. Cold gas thrusters are are ejecting gases to control satellite altitude. The next one is satellite separation test. The satellite is separated by releasing the clamp bolt, and finally this is the king motor firing test at the simulated high altitude condition. The firing time of the rocket motor was 60 seconds. This slide summarizes the flight test record of KSLV-1. First launch test was failed due to the abnormal payload fairing separation. After 10 months of first trial, second launch attempt was tried, but it also failed due to an explosion at the first and the second stage in the stage region. We finally succeeded at the third attempt. It took 3 years and 5 months from the first launch trial to the final success. We had hard times during the period, but on the other hand, we could be technically matured during this period. Now let's watch the video clip on the flight test record of KSLV-1 from the construction of the Space Center. The NATO Space Center was construction was completed in June 2013. Our first, as I mentioned, first trial turned out to be failed due to the abnormal fairing separation. The second attempt was tried in 2010, and it also failed due to explosion just after 137 seconds later. In 2013, we did third attempt, and it was the last chance because we had only 3 launch vehicles. We finally succeeded. This shows the slow motion pictures at the moment of lifting off. Fairing separation and the first stage separation. After the keyboard ignition, and finally satellite separation was successful. Now I will introduce our current launch vehicle program, KSLV-2. The KSLV-2 is a three-stage space launch vehicle developed purely by Korean domestic technologies. It aims to deliver 1,500 kilogram payload to low Earth orbit, and it is a major milestone in Korean efforts to develop our own space technology. Its first stage employs 4 75-ton liquid rocket engine, and the second stage employs single liquid rocket engine, which is a high altitude version of the first stage engine. The third stage uses a single 7-ton liquid rocket engine. This slide summarizes the liquid rocket engines developed for the KSLV-2. They are all liquid oxygen kerosene gas generator cycle engines. If we compare the first stage engine with the well-known SpaceX Merlin 1 engine, our performance is somewhat inferior, but our analysis has envisioned that we can almost take up the Merlin engine's performance by increasing the combustion chamber pressure up to 100 bars. For your reference, the current combustion chamber pressure is 60 bars. Okay, now it's time to introduce our space center. The NATO Space Center is the 13th space center in the world. It is located at the southern coast of the Korean Peninsula, as you can see on the map. Unfortunately, NATO Space Center has a defect that the possible launch direction is strictly limited to the angle around 170 degrees by the populated region in the neighboring countries along the flight path. Oops. The NATO Space Center has various facilities, including launch pad, propulsion system, and the liquid rocket engine test facilities, launch vehicle assembly and testing facility, mission control center, tracking radar, and so on. Now we are constructing a new launch site for small launchers at this region in response to the new space era. The NATO Space Center has various facilities, including, The NATO Space Center also has liquid rocket engine component test facilities, liquid rocket engine test facilities, and propulsion system test facilities. It also has a tracking station at Jeju Island. It has one radar and two telemetry antennas. We also has a tracking station at Palau Island in the West Pacific Ocean. It has two telemetry antennas and receives the telemetry data during the final phase of the launch mission. Now we will see some of the firing tests performed at NATO Space Center test facilities. This video shows the test of third stage engine at the upper stage engine test facility. It is a short nozzle version of the engine, modified to fit to a sea level testing. Its mission firing time is over 500 seconds, and so the test time is quite long. You can see on the left side, that is the firing test cell, and on the right hand side, the drone took the movie during the firing testing. The test facility left side of the upper stage engine testing is the test facility for the turboprop. Okay. Let's move to the next one. This video shows the firing test for the 75-ton liquid rocket engine at the rocket engine test facility. Its mission duration is about 140 seconds. You can see if we wait the outer view of the test facility. The green chimney facility is the combustion chamber test facility. This area is the National Park of Korea, and you can see the scene is very beautiful. After completing the engine system testing, the propulsion system level testing is performed as the next step. This is a full engine cluster first stage propulsion system firing testing. With this testing, the first stage propulsion system is verified as a whole system. You can see the 4 engines cluster at the bottom of the propellant tank on the left upper side. At this testing, the President of Korea visited our space center, and we was very nervous because our nation's president was watching our test, and fortunately we succeeded the testing. In the course of our development, we encountered a bunch of technical adversities which can cause a severe delay in the program milestone. One of them was the combustion instability problem. We noticed this problem at the first firing test of the 75-ton thruster chamber. The combustion instability problem is a really big headache. It is a very well-known story that the same problem has also occurred to the United States F-1 engine during their Apollo moon lander program, and it caused a huge penalty on the development cost and the program schedule. Personally, at that time, the hardware was under my team's responsibility, and my team had a hard time to recover to solve the problem. Anyhow, we found the solution and solved the problem finally. We also encountered unexpected problems, such as an explosion of an engine. This video shows the case. It was a second stage engine firing test in the vacuum cell. The explosion was caused by some problem in the supply of ignition fuel. By this accident, the engine was completely disintegrated, and the test facility was also severely damaged. It took more than 6 months to recover the test facility, and it took about $750 million US dollars to recover the test facility. Anyhow, we overcame all the problems, and finally we became to build our own launch vehicle by ourselves. This video shows the construction of the KSLV-2 launch pad and its first flight test. We are staking the launch tower, and the tower is ready. It was the first flight test. Fortunately, however, the first test flight was not completely successful. The cause of a partial failure was found to be premature shutdown of the third stage engine. The failure review board investigated the cause of failure in detail and concluded that it was caused by insufficient consideration of the buoyancy force exerting on the helium tank within the liquid oxygen tank. The buoyancy force increases in proportion to the vehicle acceleration. the helium is used to pressurize the tank. Our calculation says the buoyant force of almost 500 kilogram force was acting on the helium tank. So our structure was not robust to hold that much weight. It's the second test flight performed last week, June 21st. The payload was successfully inserted into the orbit with good accuracy, and accordingly, the test flight has been proven to be completely successful. By this success, Korea has been enlisted as the seventh nation capable of delivering over 1 ton's payload to a low Earth orbit. This picture is recorded by the onboard camera. Second stage is separated and the third stage engine has been ignited. And the satellite is separated. Okay, from now on I will briefly explain our future plans. As the post-KSLV program, KSLV-2 Advanced program has been approved by our government, and this program is currently undergoing from this May. It is a 5-year program with $573 million of budget. 4 times of launches are scheduled based on our national space development plan, and we have the payload assigned for each launches as listed below. But as compared to the capability of the launch vehicle, which is 1,500 ton, the gathered satellite mass is way lower than its capability. So we have more power to accommodate more satellites. Regarding the Korean next generation launch vehicle called KSLV-3, the president of KARI proposed a consolidated satellite launch vehicle development plan at the third Seoul Economy Space Forum last year. The vertical axis on the left picture, the vertical axis denotes payload mass, and the horizontal axis defines launch missions. The bold red line indicates the capability of the current launch vehicle, that is to say the KSLV-2's capability. And the president of KARI proposed a new generation launch vehicle having the capability indicated by the bold green line. The idea was inflected into our new proposal for the next generation launch vehicle development plan submitted to our government. He also proposed the possibility of launching a geotransfer orbit mission satellite at the location designated by a red dot on the right figure. That is to say, the sea launch to acquire the launch direction to the southeast direction. This slide provides you a brief introduction of our next generation launch vehicle program. The objective of the launch vehicle will be providing space transportation capability according to the National Space Development Plan. The development period will be 8 years from next year, and the development cost will amount to 1.61 billion US dollars. The payload will be large-scale satellite, geotransport orbit, and space exploration spacecraft, etc. As compared to the KSLV-2, which is a 3-stage launch vehicle, the new launch vehicle is reduced to the two stages. This has several advantages. The first stage used 5 LREs having 100-ton thruster, and its second stage uses 2 LREs having 10 tons of thruster. The engines employ stage combustion cycle for higher performance and also have re-ignition or multiple ignition capability. This slide compares the capability of new next generation launch vehicle to the currently available launch vehicle. The new launch vehicle will be capable of delivering 10 tons to 200 kilometer low Earth orbit and 3.7 tons to the GTO. Lunar transport orbit mission as well as the Mars transport orbit mission are possible. Okay, this is my last slide. We are also working on the reusable launch vehicles. As a part of this research, additive manufactured methane, LOX, liquid rocket engine research is currently undergoing, and also the vertical takeoff and the vertical landing demonstrator is under study. We are also doing space plane researches. The space plane can reach the space as a payload of a space launch vehicle, or as the upper stage of 2-stage to orbit, or a 3-stage to orbit space vehicles. The ultimate goal will be the SSTO. This video clip shows the 20% reduced scale of our space plane. From next year, we will be start researching on the space launch vehicle up to 40% reduced scale. Okay, that's all I prepared for today.
Thank you very much, Dr. Choi.
One more thing. I wanted to express my last thanks to your language, but unfortunately I don't know your language, so I hope the Google Translator did a good job for me. Thank you.
Thank you, Dr. Choi. I confirm that your Spanish is perfect, grammar and everything. Wording is good. So thank you again. I'm afraid that since we're a bit delayed in time, we can only have like one question from the audience. Can I see any hands? Dr. Duarte, please.
Succeeded, and that's a very good lessons for countries like Mexico, and I hope we can share that experience with you. And my question is very simple. You mentioned that you are planning to develop reusable launch vehicles. When do you foresee to have a reusable launch vehicle in Korea? And why are you using methane and liquid oxygen and not hydrogen and liquid oxygen.
Okay, in my institute, two groups of researchers are working on the liquid on the launch vehicles. The one group is the middle class and the larger class, the launch vehicle, and the other group works for the small scale launch vehicles. So currently the reusable launch vehicle is being studied by small launch groups. And also in our next generation program, we included the budget for the studying reusable launch vehicles. So our next generation launch vehicle does not have the full capacity for the reusable launch vehicle, but it has the capability to test the capability of the being reusable launch vehicle. It will not be a commercially benefitable version, but it will be useful for the research purposes.
Thank you. It seems that we have 2 minutes for one last question. One last question from the audience, please. There is one more from the lady up there who raised her hands earlier. Madam, please. Mike is just...
안녕하세요. have the agenda. The agenda is the following. We have the project introduction, project consortium, partners, expertise, roles and responsibilities, project organizations, overview of the project plan, next steps, M1, M6, and conclusion. So, we begin with the project introduction. The first question is, what is Galileo? Well, Galileo is a European Global Navigation Satellite System, GNSS, providing improved positioning and timing information with significant positive implications for many European services and users. Currently, there are navigation systems such as GPS, is the American GPS system, the Russian GLONASS system, and the China's Beidou system, and of course, the European Galileo system. And in a few minutes, I will show you a short video with more information, more details. Of course, with the Galileo system, we have different applications, several applications, for example, in the Internet of Things, location-based services, emergency, security, and humanitarian services, science, environment, weather, transport, agriculture, for example, civil engineering, and open services, search and rescue services, public regulated services, and we have applications in several sectors, for example, in aeronautics and automotive, for example, agriculture. So I have a short video. Please, it's possible to.
Satellite positioning has become a vital part of our everyday lives and is a key for farming, science, precise timing, and emergency response. We use it in our phones, cars, planes, trains, ships, and thousands of other applications. Initially, it was powered by an American system, GPS, or Global Positioning System. A few years later, a Russian system, GLONASS, was introduced. In 2016, Galileo, the European Global Navigation System, launched its initial services. So what is Galileo, and what makes it different from other constellations? Galileo is a European state-of-the-art system that provides highly accurate, guaranteed global positioning and super precise timing. Once fully deployed, Galileo will consist of 24 operational satellites and 6 in-orbit spares, 23,000 kilometers above the Earth, supported by a range of terrestrial sensor stations and control centers around the world. Galileo is autonomous, but also interoperable with existing satellite navigation systems, and many devices combine 2 or 3 constellations to increase accuracy and reliability. While it can work with other systems, Galileo is unique. First of all, it's European and under civilian control. All other systems are operated by the military, so it provides Europe and European citizens with independence and sovereignty. Galileo also provides a range of new services, including search and rescue, PRS, a secure service for government applications, and a more precise positioning for commercial applications. By offering dual frequencies as standard, Galileo will in fact deliver new levels of real-time positioning accuracy and substantially improve availability of the service under the most extreme circumstances. By deploying Galileo, Europe also minimizes the risk of other navigation systems being switched off or degraded. Galileo is the result of unprecedented European cooperation and innovation to offer people across the globe a new, reliable, independent civilian navigation and timing system that will power limitless applications.
Okay, thank you. Now I'm going to talk about the project Galileo Information Center for Mexico, Central America, and Caribbean, in collaboration with the European Commission and the company Telespacio Ibérica from Spain. Project information. The Galileo Information Center for Mexico, Central America, and the Caribbean is the information center on the technologies and programs of European global navigation satellite systems. And we provide information, training, and support to the satellite navigation industry in Mexico, Central America, and the Caribbean. The Galileo Information Center provides support services to satellite navigation industry, application, developers, and users in the following countries. Of course, in Mexico, Central America, for example, Costa Rica, El Salvador, Guatemala, Honduras, Nicaragua, y Panamá. Y the Caribbean, for example, Venezuela, Trinidad y Tobago, Jamaica. What are the objectives of the center? The main objective is ensure and improve the visibility of European satellite navigation activities in satellite navigation and localizations to scientific programs, for example. In general, they are working on system development, for example, in mission definition, satellite manufacturing, ground segment manufacturing, and system operations, and launchers, launch services, satellite mission control, for example, Galileo security operation, Galileo hosting of one of the two, Galileo control center, for example, and applications and services, for example, pilot programs, using terminals. And we have more information about El Espacio Ibérica. Another company is Geotecnologías. And the purpose of the company is to provide services and products for geographic informations, system and global position system. Provide installation and support to various institutions such Registro Nacional, Instituto Geográfico Nacional, local governments, University too, for example, Universidad de Costa Rica, Universidad Nacional, Instituto Tecnológico de Costa Rica. The role of the company within the project is to organize institutional meetings, support interactions, and support the interaction with the chambers of commerce of Costa Rica, Guatemala, Nicaragua, for example. Sorry. Identification of relevant markets and stakeholders, promotion and awareness raising of European GNSS programs, facilitation of joint industrial collaboration between Latin America and European partners, for example, education. Oh, sorry. The role of our university is to host the Galileo Information Center and work in close cooperation with the Polytechnic University of Mexico from Spain. Our university generate several strong research publications and patents in diverse areas such as robotics, computer science, telecommunications, aerospace engineering, mathematics, physics, human-computer interaction, history, philosophy, among others. Some reference. We have experience in space research projects with application in space telecommunications, automotive and aerospace, close collaboration with the industrial sector, mainly in electromagnetic compatibility tests, and development of satellite projects with social applications, experience in designing and implementations of antennas and microstrip technology for space and terrestrial applications, mainly for GNSS systems, experience in the implementation of earth stations for reception of satellite signals in very high frequency, ultra high frequency, L, S, and X band. Other of our activities in this project are educations and training on GNSS related uses in collaboration with Polytechnic University of Madrid. Cooperation between universities from Mexico and Spain to provide high-level education, including PhD degree, provision of course an organization of training seminars in the field of GNSS technology and applications, and promotion and demonstration activities relating to training. Here I show you some pictures, images of the advanced technology unit, host of the Galileo Information Center in Querétaro, stays here in Mexico. It's important to tell you that our unit is a member of the International Aeronautic Federation. Project organizations. Now, I will briefly tell you about the project organization. Here I show you our project organization, develop knowledge of local GNSS markets, disseminate information concerning European GNSS programs and related applications, promote and support development of GNSS applications, collaboration at academic level, courses and training sessions in the field of GNSS technology and applications, and collaborations at industrial level and institutional level. What is the project plan? Oh, we have different activities, several activities in collaboration with the Telespacio Ibérica, with the Polytechnic University of Madrid. We need find new applications in different sectors, aeronautics, in automotive sectors, and space sector, for example. And finally, I have some conclusions. Strong project consortium, local and European partners, industrial and academic level, close to local and European institutions, clear project pacifications, means to overcome the pandemic constraints, coordination activity with the Galileo Information Centers, success of the Galileo Information Center for Mexico, Central America, and the Caribbean, some promotion of EGNSS programs in the region, ground knowledge on EGNSS, industrial cooperation, new alliances, industrial cooperation, of course, foster the development of EGNSS applications. Of course, for us, the project is very, very important because we are working with different institutions in Mexico and Europe. It's very, very important, the model for us, because we need to find new applications with impact, so social impact in Mexico, in Latin America, in Caribbean. If you require more information, the project has its official website. You can find more information, past seminars, webinars, courses, if you require more information. Of course, in here I leave the contact, Maria Mota. She is the main coordinator of the project in Mexico and Spain. Thank you very much for your attention.
Thank you very much, Dr. Ramirez. I am afraid that since we're way behind schedule, we only have time for one question from the audience. So if anybody is interested, please raise your hand. I see none. So thank you very much again, Dr. Ramirez. So we're just two presentations before the end of the day, and there is one comment before we start the other one. Our next presentation, session number 9, it's going to be in Spanish. So for those who require translation, we will give like 2 or 3 minutes so you can come. Could you please come back to the left-hand side of the room and get your headset so you can have like simultaneous translation? It will only take a couple of minutes, and then we start with the next presentation. Thank you very much. And just one comment that I received, you need like one ID just to give before you get the headset. It's just a very quick, right, yeah. Sorry for the inconvenience.
Muy buenas tardes a todas y a todos los asistentes.
Doctor,
a
si me permite un segundo, porque están tomando sus audífonos para la traducción simultánea, porque usted va a hablar en español. Si me permite un par de minutos, le agradezco.
Sí, cómo no.
So I kindly ask to the audience who do not speak Spanish, if we are ready, then I think that we can start now. So the next speaker on our list is Mr. Jorge Gómez Villarreal, and the name of this presentation is Space Cooperation Interest for CDA IPN. He will explain what is these acronyms are, and aerospace sector in South Korea. Mr. Gómez Villarreal, he is Technical Director of the National Association and Faculties of Schools of Engineering. He is the Director of Higher School of Mechanical and Electrical Engineering of Instituto Politécnico Nacional. He is founding partner of the company Services and Fabrication in Engineering. He's federal deputy, actually she's a congressman, and he is an advisor to the head of Department of Federal District and Director of Space Development Center of this university. So thank you very much. Dr. Jorge Gómez Villarreal, puede iniciar cuando usted lo desee. Muchas gracias.
Muy buenas tardes a todas y a todos los distinguidos asistentes a este workshop Corea-México. En particular, el tema con el cual se titula mi intervención es muy concreto: intereses de cooperación en materia espacial del Centro de Desarrollo Aeroespacial del Instituto Politécnico Nacional y el sector aeroespacial de Corea del Sur. Entiendo que puede preguntarse por qué tan concreto este tema. Y la respuesta es que ya previamente se había tenido en 18 un workshop con los tecnólogos de Corea, la agencia mexicana y los tecnólogos del Politécnico. Y en ese contexto se ha venido avanzando en una serie de temáticas que hasta este momento han anudado fuertemente la relación en materia aeroespacial entre el Centro de Desarrollo Espacial del Politécnico y las instituciones correspondientes de Corea del Sur. Voy muy brevemente a plantear qué es el Centro de Desarrollo Aeroespacial del Politécnico, para todos aquellos que no tengan noticia de él. A raíz de la creación de la Agencia Espacial Mexicana, este hecho dio origen a que en muchas entidades educativas del país se establecieran, por lo importante de la temática que abordaría esta agencia espacial, una serie de previsiones que posibilitaran trabajos unificados y de interrelación sobre temáticas muy específicas de interés en cada caso, pero profundamente vertizadas en el contexto nacional. Por esta razón, y no obstante que dentro del instituto se realizaban una serie de actividades en materia espacial, se tomó la decisión de establecer una entidad que coordinara este tipo de actividades en el contexto institucional y fuera puente en la vinculación con entidades análogas en el contexto educativo superior y de investigación nacional. En esa razón, pues, se planteó el Centro de Desarrollo Aeroespacial exactamente unos meses después de la creación de la Agencia Espacial Mexicana. Esta entidad dio origen a que en muchas facultades y escuelas de ingeniería y de ciencias en el país se establecieran elementos que permitieran un puenteo entre las capacidades de que se disponía y los propósitos y capacidades que de alguna forma requería el trabajo de la Agencia Espacial Mexicana. Este fue el caso del Politécnico, que estableció un programa específico que, como se podrá ver, si son tan amables de darle un avance a la pantalla. Uno más. Si ustedes ven ahí la serie de elementos de construir, formar, impulsar, implementar, incluir, asumir, organizar, etcétera, todos ellos son elementos que separados tienen su significación, pero que unidos todos se pueden precisar en la disposición de una institución de poder crecer, desarrollarse y contribuir en el contexto nacional en el área aeroespacial. Esta creación del CDA fue una condición profundamente importante, porque muchos de ustedes sabrán que en Latinoamérica empezó a surgir también un movimiento muy importante en esta dirección, que actualmente ya tiene muchos elementos de vinculación y que finalmente le dará, todos esperamos eso en corto tiempo, a la región, capacidades importantes en el manejo de las tecnologías espaciales. Muy bien. De la misma forma y por las mismas razones que mencioné anteriormente, el Instituto Politécnico Nacional se adscribió a entidades importantes que a nivel global manejaban y manejan políticas de profunda importancia y vinculación con el tema aeroespacial. Dentro de ellas, la UIT, en donde el Politécnico es permanente invitado y ha sido concurrente a estas reuniones, y adicionalmente en el contexto también de la Comisión Interamericana de Telecomunicaciones, la CITEL. Esto es importante porque a raíz de los acontecimientos que previamente mencioné, de las participaciones en estas entidades multinacionales, en esencia dependiente, la primera de las Naciones Unidas, y la otra, una condición análoga, pero en el ámbito regional latinoamericano, sí, el Politécnico decidió hacer un esfuerzo importante en esta dirección y con ello establecer una conexión que pudiera permitir el enlace con el resto de países de la comunidad latinoamericana y segundo, el poder proporcionarle a la comunidad politécnica primero y mexicana en segundo término, y esto es por la obligatoriedad específica de la propia condición donde está incrustado el CDA, elementos que le permitieran una participación internacional en temas vinculados al espacio, a las comunicaciones, a las radiocomunicaciones, etc. De la misma forma, desde 18, el Politécnico atiende por invitación expresa la Conferencia Internacional de Astronáutica. Planteo esto como un antecedente que probablemente muchos de los tecnólogos coreanos ya lo sepan por las múltiples ocasiones en que hemos tenido relación y vinculación directa en esta temática, pero para el público en general, el por qué de alguna forma sí estoy planteando estas cosas. Hace un tiempo se planteó en el nivel de las universidades que tuvieran mayores capacidades en el ámbito espacial el desarrollo de un proyecto de un par de nanosatélites con propósitos diversos y que pudieran iniciar para estos elementos del ejército el inicio también de una cierta actividad que no tan solo le es propia, sino necesaria. En ese contexto se involucraron de manera muy decidida la Universidad Nacional, el Instituto Politécnico Nacional y el CICESE de Ensenada. Esto dio como resultado el que se pudieran desarrollar un par de nanosatélites de 3 unidades, que los dos afortunadamente están en órbita y andan alrededor de la Tierra, cumpliendo la función para la cual se les diseñó. A partir de ese momento, en el instituto se planteó la necesidad de establecer un proyecto interno del propio instituto que de alguna forma, tomando en cuenta las experiencias y las capacidades al respecto, pudiera dar origen a un proceso que permitiera crecer con rapidez en este ámbito. Y esto generó el proyecto IPN SAT-1 actualmente en curso. ¿No le quieren dar vuelta por ahí? Más adelante, por favor. Más. Ahí está. Ahí se puede ver si se amplía un poquito, aunque se acaben los márgenes. No. Ampliar la figura. Bueno, es difícil que se pueda precisar por todos, pero esta figura plantea ya el esquema de este satélite a que me refiero. Sí, plantea su arquitectura general, plantea los esquemas de participación institucional que le han permitido su desarrollo y plantea una condición que ha permitido el que se pudiera ir desarrollando con rapidez. El establecimiento y desarrollo de proyectos asociados al proyecto central, que es el proyecto del Instituto Politécnico Nacional llamado IPN SAT-1. ¿No la pasan a la siguiente, por favor? Este tipo de proyectos asociados se vertizan todos en el proyecto general y Los menciono muy brevemente: el abastecimiento y gestión de energía para sistemas espaciales, prototipos espaciales y equipos satelitales, sistemas de estabilización, relación y fomento con el sector industrial para la obtención de partes y elementos de la calidad y características necesarias, y otros proyectos que análogamente se han desarrollado o se desarrollan al amparo del proyecto principal. Este proyecto principal tiene una característica importante que hay que mencionar. Y todo esto que estoy estableciendo debe de ser motivo, en su caso, de una vinculación con los sectores de Corea del Sur que nos visitan hoy por los elementos que voy a mencionar. Este proyecto ha dado lugar a que se inicie el proceso de construcción de laboratorios espaciales del Instituto Politécnico Nacional. Y con ello hemos tratado de establecer vinculación con todas aquellas entidades que o ya los poseen o que están en el proceso análogo al que nos encontramos nosotros. Y de ello, los amigos coreanos ya tienen noticia, pero también nos sería muy importante que en particular se asumiera, como lo mencionaré un poco más adelante, una potencial convergencia en cuanto hace a este tipo de suministros de laboratorio que de alguna forma, en el caso de Corea del Sur, se tienen ya bastante desarrollados. Asimismo, hay un proyecto interesante que lo menciono, y con esto no quiero decir que nomás tengamos dos proyectos. Menciono los que están muy vinculados con la temática que nos trae el día de hoy. Este proyecto es el proyecto aeroespacial TPEU. ¿No le quieren dar vuelta ahí a la imagen si están tan amables? Ahí está. Este es un programa que se ha venido desarrollando entre la Universidad Nacional y el Politécnico en el desarrollo y construcción, puesta en la atmósfera y recuperación de toda una serie de globos sonda que nos han venido permitiendo ir probando la instrumentación. Estamos hablando claramente, y todos lo sabemos, que el satélite, un nanosatélite como el que mencioné de 3 unidades, se maneja en una órbita de 450, 550 kilómetros. Pero nos es muy importante el poder ir probando en condiciones de vacío muchos de los instrumentos que se aplican en el proyecto satelital. Esto se trabajó con NASA y se sumó a un programa de NASA que pone los globos por allá a alturas hasta donde es factible que este tipo de elementos puedan subir, y probamos toda una serie de placas, circuiterías y demás elementos constitutivos de esto. En este caso, este proyecto se llama TPEU, ya está en su tercera versión, porque ya van 3 experiencias importantes que se lanzan a 50 kilómetros, 60, 70, y que nos han permitido establecer correcciones, modificaciones en lo que es la instrumentación del cuerpo básico del satélite IPN Saturn. Por ahí en la siguiente, si son tan amables, puede verse en una forma muy descriptiva cuál ha sido el rol de este programa de globos cesta, en donde se llevan todas las partes que nos interesa probar y verificar su comportamiento, aunque no son alturas de 500 kilómetros, pero sí nos permiten ver una serie de factores y tener al menos cierta seguridad de su funcionamiento en condiciones ya extremas bajo el punto de vista de lo que es la superficie terrena. Muy bien. Me refería yo hace un rato al satélite IPN-SAT-1 y mencioné que tenía una característica un poco diferente a lo que normalmente estos artefactos tienen. En este satélite el Politécnico pretende probar un sistema experimental de comunicaciones ópticas satelitales, es decir, comunicaciones vía láser. Y esto es muy importante porque las comunicaciones satelitales han llegado a un límite tecnológico en términos de la cantidad de información transmitida. Por lo tanto, es necesario manejarse en frecuencias mayores que puedan satisfacer la demanda de sistemas modernos, y esto es plenamente factible con el manejo de sistemas de comunicación vía láser. Ciertamente en muchos lugares están un tanto más desarrollados, en otros se inicia, pero parece que hay una firme claridad de que este tipo de sistemas de comunicación permitirán el poder tener acceso, sí, a este tipo de comunicaciones satelitales que hoy ya han o están llegando a su límite. Esta experiencia, este sistema de comunicación vía láser, va adicionado en el IPN-SAT-1 como una más de sus cargas útiles, que esperamos pueda permitirnos obtener información que dé lugar a nuevas experiencias que vayan perfeccionando este sistema. Créanme, todo el mundo se lo sabe seguramente, que esto es algo que ya llegó para quedarse, que cada vez se va a perfeccionar más y que en un rato corto será de uso común, ¿sí?, a nivel planetario. El Politécnico está planteándose en estos términos de desarrollo con esta experiencia como segunda carga útil en el proyecto satelital IPN-SAT-1. Yo, con todo gusto, a quien tenga interés le podría enviar la lista de todos los proyectos que se desarrollan en el Centro de Desarrollo Espacial. No los menciono aquí por la cortedad de tiempo de que se dispone y porque es importante plantear algunas otras condiciones que me parece y que he escuchado esta mañana y que siento coincidentes totalmente con lo que pensamos nosotros al respecto de esta situación. La primera de ellas es establecer una primera etapa de 23 a 25, o sea, de 2023 a 2025, en donde, una vez ya teniéndose la experiencia de IPN-SAT-1, seamos capaces de poner otros dos más, en donde otros dos nanosatélites de 3 unidades o 4, eso ya se determinará en su momento, en donde ya podamos avanzar en este tipo de experiencias de comunicación, por una parte, y que por otra parte esto permita tener un camino accesible y fácil para sus pruebas finales y su lanzamiento. Estoy mencionando esto porque es evidente que existen países con las capacidades de poder poner allá arriba satélites que sean desarrollados por la comunidad universitaria, por una parte, o que puedan ser desarrollados por laboratorios de investigación muy específicos. Pero aquí nos estamos refiriendo a las grandes instituciones nacionales, en que independientemente de los nombres, tienen el mismo propósito y siempre se han sumado al esfuerzo del gobierno nacional para poder efectivamente proyectar a México. En este sentido, pues, la primera etapa, sí, de 23 a 25 implicaría el desarrollo y puesta en órbita de 2 nanosatélites más, y de 26 a 30 meternos conjuntamente con otras instituciones o todas ellas bajo la coordinación de nuestra agencia espacial, que ordena y establece condiciones que posibiliten el desarrollo generalizado en el medio espacial. Pero estamos hablando de un satélite pequeño, un satélite ya de 50 kilos, el cual evidentemente permitirá una participación plural y una convivencia de tecnólogos en los diferentes subsistemas que conforman el satélite adecuado. Este es nuestra meta. Para 25, 2 nanosatélites más, y para 30, poner allá arriba un satélite pequeño de 50 kilos. En ese propósito, hemos elaborado todo un plan y un programa para el establecimiento de los laboratorios espaciales del Politécnico, que implican, y los nombres tal vez por genéricos no son totalmente descriptivos del propósito, pero quien está metido en esto entenderá que esto es lo que está ocurriendo. Un laboratorio de instrumentación con todas las implicaciones que este trae. Un laboratorio de integración y validación. Un laboratorio de pruebas, una estación terrena y los talleres generales que permiten el poder realizar las operaciones cotidianas al respecto. Quiero mencionar que esto que hace un tiempo era un sueño, en este momento, a través del director general del instituto, se encuentra en proceso de autorización el programa de inversión correspondiente para poder efectivamente cristalizar esta necesidad vital para el desarrollo de los programas y de los proyectos satelitales en México. En este contexto, y ya voy a terminar, ya no voy a llevarme más tiempo, planteamos, porque así se llama el título con el cual yo registré mi intervención, ¿cuál es el tipo de vinculación que en este momento nosotros estamos sugiriendo, planteando, ¿sí?, en el caso del Politécnico y las instituciones coreanas dedicadas a la investigación y al desarrollo espacial? Nos conocemos ya mucho porque hemos tenido encuentros múltiples, por eso me refiero con tanta confianza a este grupo de amigos tecnólogos coreanos. Muy particularmente, nosotros quisiéramos tener una condición de vinculación sobre el desarrollo de software para aplicaciones satelitales de meteorología, particularmente de meteorología. Alguien dirá, oye, pero ¿por qué? Se dice fácil, pero quienes conocen de esto saben que no es ninguna perita en dulce. Segundo, un programa de vinculación para realizar pruebas satelitales, en donde se adquieran capacidades y experiencias paralelamente a que se conforman las estructuras de los laboratorios satelitales. Un programa de estancias académicas y de investigación en instituciones coreanas relacionadas con el desarrollo de la tecnología satelital. Aquí quiero decirlo, y seguramente algunos de nuestros visitantes coreanos lo podría confirmar, que esto ya lo hemos hecho en el pasado reciente. Y no únicamente el Politécnico, la universidad y otras entidades educativas. Es decir, ya hemos tenido estancias, ya hemos tenido participación en experiencias específicas vinculadas a las tecnologías espaciales, y por ello es que estamos planteando aquí el establecimiento de estancias académicas muy específicas y de investigación en instituciones coreanas en el ámbito espacial. El siguiente punto a que yo me refiero en cuanto hace a cuáles son las pretensiones, puntos de vista y tal vez propuestas nuestras de vinculación, sería un programa de entrenamiento para el diseño, construcción y prueba de vehículos espaciales. Esto en Cádiz. Así de concreto. El siguiente punto sería el desarrollo conjunto de talleres CARI-IPN en México y Corea para la capacitación a detalle de tecnólogos mexicanos cuando estamos planteándonos. Si bien ahorita un club de 3, estamos planteándonos ir preparando la infraestructura para un satélite pequeño, como los que mencionó en su intervención mi estimado amigo de la Agencia Espacial Mexicana aquí presente. Los últimos puntos que se sugieren son los de vinculación con la Oficina Comercial de Corea, COTRA, para el desarrollo, para la implementación de programas de desarrollo de la industria nacional. La industria nacional en materia espacial está iniciando, pero tiene una perspectiva formidable. Los 6 grandes conjuntos que ahorita trabajan en el país tienen y aportan aproximadamente 12.5, 12.6% del PIB, del Producto Bruto Interno de México, y apenas está empezando. Y ahorita no ha llegado más que a la mitad de sus posibilidades y de sus propósitos cuando fueron establecidos, ¿sí?, estos centros. Esto nos indica, primero, que todos estos desarrollos en que estamos involucrados tienen sentido en la medida que puedan ser trasladados a la industria y conformar con ello una integridad, ciencia, tecnología, industria, abasto y participación internacional. Si esto se logra, es factible entonces que de alguna forma estemos completando el círculo, ya no sé si decir virtuoso o vicioso, a que nos ha llevado siempre el desarrollo económico, social y científico de las naciones. Esto es un aspecto que casi no se ha tocado con formalidad. Hay, por parte de la agencia y por parte de varias instituciones, intencionalidades manifiestas en cuanto hacia la industria espacial. No estoy hablando de la industria aeronáutica, de la industria espacial, pero yo siento y creo que muy rápidamente, si nos sentamos y nos ponemos de acuerdo, externos y internos, vamos a encontrar vías, caminos y sobre todo objetivos a lograr en un plan que pueda complementar la actual acción en materia aeronáutica con la parte espacial. Esto nos lleva a que sí sería importante que COTRA o bien las entidades coreanas correspondientes pudieran entrar en vinculación con nosotros para este programa de equipamiento, ¿sí?, de todos los laboratorios espaciales que el Politécnico, en un periodo no necesariamente muy pequeño ni tampoco enorme, piensa establecer en sus instalaciones con el propósito que ya se menciona. Estos son los puntos que le dan base al título de esta presentación que hago. Estos son, en esencia, los factores que nos permitirían pensar en una potencial y sobre todo conveniente bilateralmente hablando, ¿sí?, ampliación de la relación en materia espacial con Corea. Y esto, amigos invitados de Corea a este taller, queda en sus manos. Nosotros estamos a su disposición. Muchas gracias. Perdón que lo hiciera en español, pero como tengo que emplear muchos terminajos y formas, preferí ser muy claro y pedirles a las amables damas que nos están auxiliando que para el caso de los compañeros coreanos establecieran el proceso de traducción de toda esta cascada de palabras y ideas que he vertido al respecto. Muy gentiles, si hay alguna pregunta, con gusto.
Muchas gracias, don Jorge Gómez. Tenemos los 3 minutos que le quedaban, se convirtieron en 10, entonces tenemos tiempo para media pregunta. No.
Media. No, con gusto podré estar, si, como veo que nada más es una, en un momento más me traslado y con gusto la contestaré para no irle quitando más tiempo a la reunión y no con ello ya pecar más de lo que hice.
Tenemos un par de minutos, aguánteme.
Thank you for the detailed presentation. I'm Hee-Kwang Eun in CARI, Satellite Integration Test Center. I'm providing for test service for CubeSat in Korean University, but I don't know the test service itself is a good agenda for CubeSat in Mexican University due to long travel distance.
A mí me parece que su pregunta es profundamente importante y muy particular, por lo cual, con gusto, si usted no tiene inconveniente, la comentaré con usted. Y esto no va en falta de beneficio para todos, sino por la particularidad que de alguna forma implica. Les agradezco su atención a todos. Muchas gracias.
Thank you very much. We say goodbye to Engineer Jorge Gómez with applause, please. Now we go to the next session, number 10, named University Space Program at UNAM. It's with Dr. Jose Francisco Valdez Galicia. Jose Francisco Valdez obtained his bachelor degree from the Science Faculty at the National Autonomous University of Mexico, UNAM, and his PhD from Imperial College, University of London. He was director of the Geophysics Institute at the UNAM from 2005 to 2013. He is the Director General of Innovation at the Science Ministry of Mexico City Government from 2014 to 2015. And since 2017, he is the head of the University Space Program at the UNAM. He has published 117 scientific articles in high-impact peer-reviewed journals that have received more than 5,000 citations according to the Science Citation Index. He has given conferences in Mexican and international congresses, outstanding among which are 20 invited conferences. He is editor-in-chief of the Geofísica Internacional peer-reviewed journal from 2014 to 2017. He is principal investigator of the cosmic ray detectors at the UNAM main campus in Mexico City and at the summit of the Sierra Negra volcano in the state of Puebla. He's been professor at the faculties of Science and Engineering at UNAM. He has supervised doctoral, master, and bachelor thesis. He received the Manuel Maldonado Cuerdel Medal from the Unión Geofísica Mexicana in 2013 and the Mario H. Acuña Award from Asociación Latinoamericana de Geofísica Espacial, ALAGE, in 2018. Please welcome Dr. Francisco Valdez Galicia, who's sending us his image from abroad. Adelante, doctor.
Thank you for the introduction. Thank you very much for the invitation to the Mexican Space Agency and the Korean Space Agency. And I apologize not being present today since last night I was informed that a very close member of my family is with COVID. So doctors recommended that I remain in home for a few days. Thanks to the nowadays technology, as has been the case for the last 2 years, we can communicate and I'm able to make this presentation. So,
doctor. Estamos teniendo un pequeño problema técnico con el audio. We're having a small technical problem with the audio from Yes, we can hear you here in the room, but it's not going to the internet, your audio.
Okay, but I have my audio on.
Just give us a minute. It's
Shall I wait?
yes, please, a second.
Okay.
Doctor, ¿nos puedes dar unas palabras de prueba?
1, 2, 3, probando. 1, 2, 3, probando.
Sí, listo. Bien, parece que ya se resolvió. Adelante.
Okay, if you have not heard me, I apologize with you not being present since one of my very close relatives has been diagnosed last night with the COVID, and I have been advised not to go out from home for at least a couple of days. So thanks to the marvel of the technology, I can now share my presentation with you, and at the same time thank the Mexican Space Agency and the Korean Space Agency for the invitation to the UNAM space program for this workshop. The UNAM space program is a very young entity. It was created at the end of 2017 with purposes and objectives very similar to those mentioned by my friend Jorge Gomez Villarreal in the National Polytechnic Institute. So with a different emphasis in different questions, since we have been also made the duties of popular science to try to create a culture in space science which does not exist in Mexico, and also to collaborate intensively in the human resources preparation. In that, we have given courses and we have prepared CANSAT contests and other types of contests. And but we have also a couple of satellite projects now in which we have tried to incorporate several institutions of the National University, which you see here, the Institute of Astronomy, the Institute of Geography, the Faculty of Engineering, and the Geophysics Institute have been involved in the projects that I'm going to mention now. The first project in which we are involved is, we called it the Ixaya project, which in the Mexican Nahuatl language says, means open your eyes. So we want to open our eyes to see the Earth. This is an Earth observation project that searched from several consultations we made with the National Geographic and Informatics Institute, with the National Center of Disaster Prevention, and other national institutions that are using images. And we were trying to build up a project that could be useful for them. So the first ideas came when we realized the amount of losses that are in the country in general, but close to the Mexico City in particular, by fires
and other accidents, so that around 2,000 hectares were lost in just 1 year, and the amount of economic losses were enormous. So the government of the city was interested in creating a project like this. So here you see a fire, and you see the images that you can get from satellites nowadays. But our aim was to obtain satellite images in the infrared, thermal, and the RGB bands with relevant information for applications useful for civil protection institutions, ambient monitoring, and urban development. We want to detect and produce alert about risk zones to contribute to hotspot detection generated by fires, infrastructure accidents, or other natural phenomena during the first semester of 2019. For example, nearly 2,000 hectares were lost of vegetation, were affected. The Mexico City urban zone. Presence or absence of monitoring and estimates of vegetation of density, monitoring of green zone invasion or clandestine felling of trees and vegetation in protected regions. These were the main ideas, and the main goals of the mission is take images from LEO, from a low Earth orbit, from 500 to 600 kilometers with a 3U CubeSat in the visible and infrared spectral zones to detect and localize hotspots. The second goal is to demonstrate that the conceptual and technological viability of Earth observation with nanosatellites with the aim to scale this idea. So this is a concept test, so that we can scale this project to a satellite constellation with low cost and produce data processing of satellite images to monitor risk by natural phenomena such as forest fires, but others too. And also to send alerts to civil protection authorities and risk mitigation entities so that they can produce their own alarms in their own terms, as they are authorities. We are not authorities. We can produce the alert, but not the alarm. Who are the promoting entities of this project? Well, of course, the Space University program, the High Technology Unity of the Faculty of Engineering, the Geographic Institute, the Institute of Astronomy, and we have incorporated 2 national laboratories, the National Laboratory for Space Engineering and Space and Automotive Engineering, the National Laboratory of Earth Observation, and of course the Secretary of Science, Technology, and Education in Mexico City. This is a project that will last for a couple of years. We are actually in the conceptual design, which will take us, we estimate, around 3 to 5 months. And then we came the different stages as the test design, the critical design, the acceptance test, the launching, and the technical and scientific reports will come at the end. This is only a very brief account of what we're thinking to do, of the schedule. So Mexico will have a level 0 images with the aim to be used in public planning actions and in the civil protection, ambient and urban environment. So a satellite which will be useful for the people, which will have immediate applications. Public sector entities may produce for the first time an alert system, as I have said, at a very low cost. The project will develop capabilities to produce remote sensing nanosatellites with all its subsystems, and to contribute to open a space technological development path oriented to product innovation to solve some of the country necessities. These are the main expected results. Of course, there are others.
We also put some attention to the SDO impacts by the United Nations, and we think we will have influence in at least 6 of these objectives, 6 of the 17 objectives. Of course, education of quality, gender equality, industry, innovation, and infrastructure, communities and cities sustainable, action for the climate, of course, because of the hotspots and the detection of vegetation loss or introduction of people in green areas, and the life of ecosystem, Earth ecosystems. So we think we can contribute to high aims of the humanity these days, as a very modest contribution, but a contribution after all. And we think it's a very low cost, because this is a project that will cost around 5,100 USD, which is much lower than mini satellites or other kind of satellites. And this could be scaled, and this budget is not much when we think about the budgets of national quality. The second project has been mentioned a couple of times this morning, is the AztecSat project, in which we are involved. We were invited by the Mexican Space Agency, and we thank for this invitation, and a project that was sparked by NASA. The background is, of course, as we have heard already, the AztecSat-1 satellite, and the need to upgrade the tracking of marine animals, and the limitations in transmission capabilities of the current hardware. And I thank my friends Salvador Landeros and Carlos Duarte for saving me some explanations, since they have touched the issue again. And I will just say that we hope to build a constellation to have transmission of data from the sea surface to the satellites and back to Earth in a very efficient manner, with new technologies, with high power transmission and high capabilities transmitters. These are the promoting institutions. Let me mention again the BOEM, the Bureau of Ocean and Energy Management, which is committed to protect and preserve the environment, and this was crucial for the university to decide to become involved in this project. The Mexican educational institutions involved are, of course, UNAM, the National Autonomous University of Mexico, the Pan American University, which is a private university, the Popular University of the State of Puebla, UPAEP, and the UNAC, University of Aeronautics of the State of Querétaro. We are one public university and 3 universities of private character, so we think it's a good combination of efforts for this purpose. I'm not going to go into some other aspects of the project because they have been mentioned this morning, but on the benefits that this will bring us. Learning, of course, preparation of human resources, students, masters, PhDs, the creation of an open database which will be accessible for everyone, the reinforcing of relevant academic curricula as the aerospace engineering bachelor studies in the UNAM and other similar studies in the National Polytechnic and other institutions. The possibility to incubate business, innovative business in the space sector. We can build scale economy since we are building 4 identical satellites. The launching, which will be provided by NASA, will be an asset for this project. And the ambient tests that will be performed both at UNAM and at NASA, which will give us the possibility to compare, test, and of course, upgrade the laboratory tests that we already have at UNAM in the state of Querétaro. The indirect benefits are, well, some space leadership in Mexico of the project, the human resources development, the possibility, of course, of having scientific and technological publications, and an integration of monitoring stations already existing in the country, which will be important for this and for the forthcoming projects, of course. The experience and space capabilities that this group has is that, well, we have 2 national laboratories involved, the Observation of Earth National Laboratory and the engineering in space and automotive specialties. There are 6 space products in review for patents. I mentioned some of them, the Nanosatellite Center of Mass Determination, Orientation Test Simulations, Nanosatellite Unrestricted 3-axis movement, and I think the last one is the proportional Hall effect has already been given the patent. So there is creative production in the group, important part of the group and the space program are also participating in the Kyoto National Nanosatellite, which will be launched later this year. And this project has been already mentioned by Carlos Duarte this morning. The group sustains good part of the aerospace engineering bachelor degree. The Galileo Information Center, which Dr. Jose Alberto was explaining a couple of presentations before mine. The suborbital flight experience that we already have in the participation in the National Committee for Space Norms. So there is experience in the group, there is the will to do it, and there is the collaboration of several entities of the university, and we are starting with a low-cost project that we think can be the spark for a new era in space activities in UNAM University, since we already had almost 2 decades ago the first launching of a satellite, of a Mexican satellite, the UNAMSat-1, which unfortunately worked for only a few hours, and then the program was closed. But then that was the main things that I wanted to talk to you, and I thank you very much for your attention. And of course, I will take comments or questions that you might have.
Thank you very much. A big applause. If there are any questions from the floor, don't be shy. It's our last speaker of the day, so you can go. Okay, Doctor, it seems that everything was crystal clear. And we thank you very much for your participation, and we say goodbye with a big applause, please.
Okay, thank you very much, and good afternoon for all of you.
Thank you very much. We thank you for your presence here today, and we remind you that the program continues tomorrow. We have plenty of sessions tomorrow. We have a full day tomorrow. So thank you very much for your attendance, and we'll see you tomorrow.